We have over 4.5 hours of mixed SAT study for you in this video, and to get the most out of it, you need to make sure to pause and attempt each question on your own first. Also, make sure to check out the timestamps if you're looking for anything specific. You're going to notice chunks of mixed practice, some English-specific practice, and some math-specific practice. Without any further ado, let's get started. We're going to start with 4 easy questions, 2 English and 2 math. And our first question here is obviously an English question. Based on the text, how would Singh and Roy most likely respond to the research in text 1? So we've got cross-text connections. As you may have noticed, I like to start with the question so I know what it is I'm looking for. And we know that we're looking for text 2's most likely response to the research in text 1. And there's 2 ways we can go about this. We could either figure out what that research is and then get some context from text 2, or the way that I'm going to do it right now is starting with text 2 and then going to that research. Governments in democratic countries function better when more people vote. However, forcing people to vote may have negative consequences. Shane P. Singh and Jason Roy studied what happens when a country requires its citizens to vote. They found that when people feel forced to vote, they tend to spend less time looking for information about their choices when voting. As a result, votes from these voters may not reflect their actual preferences. So I'm just going to give myself a little main idea here. I don't know why my text is huge. And my main idea is going to be basically voting good, but forced voting bad. Now, research in text 1. Let's see. Normally I would try to pinpoint where the research is and maybe skip some of the text, but this chunk of text is so small, I'm just going to go ahead and read the whole thing. Public policy researcher Anthony Fowler studied the history of elections in Australia, a country that requires citizens to vote. Okay, so we see the connection there. Fowler argues that requiring citizens to vote leads to a significant increase in voters who would otherwise not have the time or motivation to vote. Thus, election results in countries that require citizens to vote better reflect the preferences of the country as a whole. Okay, so I'm already seeing an issue here, voting good but forced voting bad, where text 1 seems to say forced voting good. And I wouldn't necessarily write this down. This is just to give you an idea of what I'm thinking about. So how would text 2 respond to that? I'm guessing that they would emphasize that these votes may not actually reflect their preferences, specifically because they spend less time researching the candidates. And I'll go through and I'll start eliminating. Only countries of a certain population should implement mandatory voting. There was no mention of population size in either of these texts, from what I remember. So that's out. People who are forced to vote are likely to become politically engaged in other ways, such as volunteering or running for office. That's also not what I said. Requiring people to vote does not necessarily lead to election outcomes that better represent the preferences of the country as a whole. Yes, not as specific as I would like, but yes. Countries that require voting must also make the process of voting easier. No. All right, so it's definitely going to be C. All right, this next one, we've got a function-based question. Always looking at the function of the underlined sentence. I would recommend reading through the whole thing, but really honing in on that underlined portion. So historians Tia Miles and Roy E. Finkenbein both have documented the assistance indigenous peoples gave to black freedom seekers leaving the South before the U.S. Civil War. Much of the historical evidence of this, historical evidence of indigenous peoples helping black freedom seekers comes from indigenous oral traditions. So that would be stories just told out loud but not written down, and from autobiographies written by the freedom seekers. One such narrative, so we know one such narrative is referring to one of these autobiographies, is Jermaine Logan's autobiography, which tells about how these villagers offered him food, lodging, and directions during his 1835 journey from Tennessee to Canada. So my anticipation here is going to be that this is acting as an example of one of those autobiographies that told about how indigenous peoples helped Black freedom seekers. A, it provides an example of an autobiography that describes help given by an indigenous people to Black Freedom Seeker. That is exactly what I said, so I'm going to keep that. It shows why Logan decided to write in great detail. It does not. It argues that autobiographies were particularly important sources of information. It does not. It suggests that most historians believe these villagers were more successful. Nope, it's A. And the reason that was so easy is that I had an anticipation or a prediction of what the answer should be beforehand. Always have that ready in the English section for these reading-based questions. So our first math question here is a little bit of a word problem. I do like to focus on the main part of the question here as well, just so I know what it is that it's asking. In this case, because all the answers are equations, I already know that it wants to know what does the equation look like for this scenario. So I'll actually just kind of go with that. And based on the way these answers look, we're definitely dealing with y equals mx plus b, which is a linear equation or a linear function. You can see we have h is y, s is acting as x, and then the whole number is going to be our b. An easy way to approach these is to think about what does slope represent and what does y-intercept represent. So your slope is m, and in the context of a word problem, slope is going to be a constant rate of change. And b is our y-intercept, and that is going to be a starting point or initial cost. So let's look for both of these things. Do we see a starting point? Do we see a constant rate of change? The front of a roller coaster car is at the bottom of a hill and is 15 feet above the ground. Seems like we've got a starting point. 15 feet above the ground is where it starts. So based off of that, we could just go with A and get our correct answer. But if we also want to just double check that our constant rate should be 8, if the front of the roller coaster car rises at a constant rate, it actually even has that phrase constant rate of 8 feet per second. Boom. So we're totally good there. It's A. Our next easy math question is a system of equations, specifically a system of linear equations, and it's asking for the solution. Well, this one's easy enough. Solution means where do the lines touch? I see 1 point right here, so I'm going to count my x's, 1, 2, and then my y, 1, 2, 3. The answer is 2, 3. Moving on to central ideas and details with our first medium question. Based on the text, what can be concluded about the diminishing popularity of the portrait miniature in the 19th century? So basically, why diminishing popularity of the portrait miniature is what we're going to try to focus on. Now, I'll read the text out loud, but if I were taking an exam and I came across this question, I'd be reading this in my head, but kind of skimming through and looking specifically for a mention of the diminishing popularity of the portrait miniature. A common assumption among art historians is that the invention of photography in the mid-19th century displaced the painted portrait in the public consciousness. The diminishing popularity of the portrait miniature, so this is where I'd be focusing, which coincided with the rise of photography, seems to support this claim. However, photography's impact on the portrait miniature may be overstated. So far, we would say not photography. Photography is not the main, or at least not the only cause of portrait miniatures diminishing popularity. Although records from art exhibitions in the Netherlands from 1820 to 1892 show a decrease in the number of both full-size and miniature portraits submitted, this trend was established before the invention of photography. Yeah, so basically, like I said, I think this sentence is really what we should be using. Photography's impact may be overstated, so it's not the only cause of the portrait miniature losing popularity. Let's eliminate. Factors other than the rise of photography may be directly responsible for the portrait miniature's decline. So that does go with what we were saying. I'll keep that one. Although portrait miniatures became less common than photographs, they were widely regarded as having more aesthetic merit. That has nothing to do with what I said. The popularity of the portrait miniature likely persisted for longer than art historians have assumed. That also has nothing to do with what I said. As demand for portrait miniatures decreased, portrait artists likely shifted their creative focus to photography. It also does not mention that, nor was that my anticipation. So A is certainly our answer. Our question is which most logically completes the text. That means we're dealing with an inference question. And for inference questions, I do recommend you at the very least read quickly through the entire passage so you have full context and can come up with a prediction or anticipation of how the text might end. In her 2021 article, Throwaway History Towards a Historiography of Ephemera, scholar Ann Garner discusses John Johnson, a devoted collector of items intended to be discarded, including bus tickets and campaign pamphlets. Johnson recognizes that institutes considered his expansive collection of ephemera to be worthless. Indeed, it wasn't until 1968, after Johnson's death, that Oxford University's Bodleian Library acquired the collection, having grasped the item's potential value to historians and other researchers. Hence means therefore, or according to what was just stated, the example of Johnson serves to blank. So I'm going to guess that it'll be something like the example shows that value really changes depending on the time period or by, perspective. So the example serves to demonstrate the difficulties faced by contemporary historians in conducting research without access to ephemera. Nope, that is not what I was saying. Represent the challenge of incorporating examples of ephemera into collections of libraries. No. Lend support to arguments by historians and other researchers who continue to assert that ephemera holds no value. No, because we found that it did hold value in the end. All right, it better be D because I don't like those other answers. Illustrate both the relatively low scholarly regard in which ephemera was once held and the later recognition of ephemera's possible utility. I don't love that answer, but I guess it works. It does go along with the part where I said, sometimes things will be more valuable depending on the time. So that later recognition fits with it. And, it definitely does illustrate both of those things. So D is going to work. All right, so we've got a word problem here. And word problems, you don't necessarily know what you're dealing with until you read through. Some things that I'm noticing. I see different types of packages. We have 100-pound packages versus 120-pound packages. So those are types of packages, but then we also have a total number of pounds. Total number of pounds. And we're counting packages too, right? So we're counting packages, we're counting pounds, there's different types. The reason I'm pointing all this out is when you see two different types of the same thing with different values, you're dealing with a system of equations. So what I want to do first is decide what's X, what's Y. So I'm going to say 100-pound packages are X, and I'm going to say 120-pound packages are Y. So let's write our first equation here. We know that X plus Y, all of our packages together need to equal at least 10. So we could say that they are greater than or equal to 10. That way, they're not going to go below 10, right? And then our other equation needs to account for the pounds, because remember, X and Y were the number of packages. So for pounds, we just need to include the pounds affiliated. So since each 100-pound package is 100 pounds, we would say 100X plus 120Y is going to be at most 1,100 pounds. So this needs to be less than or equal to 1,100 100. First, let's talk about what we're trying to do. We're trying to maximize the number of packages. In order to do that, we want to have as many pounds as possible. So I'm going to change our bottom equation to equal to, because to maximize, we would want to be as high as possible with equal to 1100, right? All right, so we know by setting this equal to 1100, we are going to have as many pounds as possible. Now, what can we do if this x plus y is greater than or equal to 10? Well, in order to make y 120 as big as possible, since we're trying to maximize it, we want to minimize x. Let me show you what I mean. If we rewrote this, if we moved the y over and we had, subtract y, let me change colors actually. So we subtract y and change this to x is greater than or equal to 10 minus y. So we want to minimize x, right? We want to minimize x. That means we should change this to equals, because we don't want x to be any bigger than this answer. We want x to be as small as possible. So x equals 10 minus y. All right, we've minimized x, aka maximized y. Just to make things simple, since this we know that setting this equal actually ends up maximizing y. So I'll change this to equals, because this is literally the same equation, just written a different way. And then elimination is the route I would go if you want to go ahead and write things out. At this point, you could also just plug this into Desmos. We usually cover the Desmos strategy on this channel, so just this once, I'm going to show you the elimination strategy. Basically, we want to match things up and get rid of the x's so that we answer for the y's. So in order to eliminate the x's, I'm going to multiply my top equation by negative 100. Why am I doing that? Because when I add my two equations together, negative 100x plus 100x is going to eliminate itself, right? That's why it's called elimination. So we have negative 100x. Here, let me actually move some stuff around real quick. Distribute that negative 100. Negative 100x minus 100y equals negative 1000. Then we add our two equations together. Like I said, negative 100x plus 100x, that cancels out. That's exactly what we wanted. We have negative 100y and 120y, so we have 20y left over. 1100 minus 1000 is 100. Divide by 20, and y equals 5. All right, we've got another word problem, and I want to start with the main question. It says, according to the model, what would be the head width of a worker bumblebee that has a body weight of 0.5 grams? So we know we're going to plug in 0.5 grams as body weight and then plug that into some sort of model or equation. So let's try and make an equation. According to a model, a head width in millimeters of a worker bee can be estimated by adding. All right, so let's start this. The head width we're going to say is h. H can be estimated, so we'll say that's equals, can be estimated, is adding 0.6, so that'd be plus 0.6. And I'm putting it over here because it seems like that might be our y-intercept, and this might be linear, by adding 0.6 to 4 times the body weight. So 4 times the body weight, we'll call that b for body. Okay, in grams. So as you can see, we do indeed have a linear equation. Y equals mx plus b. In this case, h is standing in for y. B is standing in for x, and our y-intercept is 0.6. Now, we already know that we just want to plug in 0.5 into body weight. That's what we determined in the very beginning. 4 times 0.5 plus 0.6. And you could plug that into your calculator, or, 4 times 0.5 is half of 4. That's 2 plus 0.6. Our answer should be 2.6. Our first hard question is going to be words in context. We know that because we have to fill in the text with the most logical, precise word or phrase. For these, I do like to read the whole thing for context, and come up with a prediction. That said, sometimes it's hard to come up with a prediction, and if you do run into that issue, go ahead and just start eliminating answers. So we've got economist Marco Castillo and colleagues showed that nuisance costs, the time and effort people must spend to make donations, reduce charitable givings. Charities can mitigate this effect by compensating donors for nuisance costs, but those costs, though variable, are largely blank donation size. So charities that compensate donors will likely favor attracting a few large donors. So because it says so, this is what we want to look at for evidence of what should be in the blank here. It's likely that charities will compensate donors will favor attracting a few large donors over many small donors. Why would you want fewer donations? Assuming that we get the same amount of money, the only reason you would want fewer donations is because the compensation for nuisance costs, whatever you're giving a donor for nuisance costs, is the same regardless of if they give you a large donation or a small donation. So those costs are largely blank donation size. My prediction will be not affiliated with, not associated with, not tied to, not connected to donation size, something like that. All right, we have supplemental to. So supplemental to, a supplement is something that you add on, right? If you think about supplements for your diet, if you take like an iron supplement, that is additional iron that you're having other than the iron from your food. I said it's going to be unrelated to donation side, so that doesn't work. And let me actually write down my prediction here just so neither of us forget. So unrelated to, or not, tied to, something like that. Predictive of. So if it predicts it, then it's very much related to it and it is tied to it. So that's the opposite of what I want. Independent of. If you're independent of something, you are not tied to it. You are not relying on it. So that works. I'm going to keep that one. Subsumed in. So here we can look at the prefix sub and think about consume. So if something gets consumed, it's eaten, it's taken in. Subsumed, we could maybe imagine it below. And indeed, subsumed is going to be like contained within something you could think of it like a smaller category. So for example, cats, dogs, and iguanas are all subsumed under the classification of animal, right? Forks and knives are subsumed under the classification of utensils. Again, it's not what we're looking for, and C is definitely going to be our answer. Our last English question is going to be some good old form, structure, and sense. I know this because it is conventions of standard English, but we don't have punctuation. So by default, form, structure, and sense. Now, of course, there are different things that can be within form, structure, and sense. In particular, it looks like we are dealing with verbs. And what is my favorite thing to do with verbs? Try the odd verb out trick. So we're not even going to look at the text. We're just going to look for an odd verb out first, and then we'll double check to make sure that we're not crazy. Hasn't been. And in case you're not aware of this trick, basically we want to match up each answer with, he or she, or with they. So I'm going to just use she here. So we'll say she hasn't been. That would be correct for hasn't been. She wasn't. She isn't. But we can't say she aren't, right? We would say they aren't. So pretty sure my answer is D. I'm going to circle it. Let me show you the magic though. Let's just double check. The artistic talents, and we do want to focus on the main noun as our subject. So the artistic is describing talents of Barbara Chase Rebound. That of prepositional phrase is also describing talents. Our main noun, our main subject is talents. All of this stuff in between commas we can get rid of because that means it is non-essential information. And then we get talents aren't. Talents are not. Talents are plural. It lines up with they. So the odd verb trick certainly worked in this case. Our first hard math question, we have some constants, and it's asking the value of not A or B, but actually AB. Technically, this is going to fall under equivalent expressions because you have these two expressions that are equal to each other. I would kind of categorize it as a constants question, a constants matching question is what I would call it, because the strategy I'm going to use is a matching strategy. And let me show you what that looks like. So one way to go about this would be, what is A? Find that out. And then what is B? Find that out. And then multiply those together. But it would be a lot easier to just find out what AB is. And what we can do is we can get rid of everything in the equations that are not attached to AB. I'll show you what I mean. So where is AB going to show up? When we multiply AX by BX, we're going to get AB, right? Is there any other place where AB is going to show up? No, A and B will never be multiplied other than that part of foiling this out. So I'm actually only going to FOIL that out for now. AX times negative BX would be negative ABX squared. So that's our anchor. Now, because AB is attached to x squared, we want to pull out everything else that is attached to x squared, because by definition, all of the terms that are at the same degree, whether it be x to the third, x squared, just x, or no x's, just a constant, they all have to be equal to each other. So I'm just going to extract things that are attached to x squared. So on the left side, is there any other place where I'm going to get x squared? Yes, there is. When I multiply 3 by 5x squared, I'm going to get 15x squared, right? So I'm going to add that down here. 15x squared minus ABX squared. And then on the right side, I'm going to do the same thing. I'm only going to worry about x squared. So we're getting rid of this, we're getting rid of this, and then we just have negative 9x squared, right? So from here, let's just isolate AB. First thing I'm going to do to really simplify this is just to get rid of x squared, because if we divide the whole thing by x squared, then all of those go away. Now I'm going to subtract 15 from both sides to get negative AB by itself. So then we end up with negative AB equals, what's negative 9 minus 15? Negative 24. And of course, if negative B is negative 24, then AB is 24. Our answer is C. All right, last question here. We are dealing with probability, it looks like. And we do have a lot down here, so just to make sure we're aiming at the right thing, let's look at the final question here. If a contestant is selected at random, what's the probability that a selected contestant received a score of 5? Okay, so I'm going to immediately start honing in on this. A score of 5 on day 2 or day 3. So let's find that first. A score of 5 would be 5 out of 5. So we're looking at this column, and it says day 2 or day 3. So basically, what's the probability of these? And a little hack for you, it says, what is the probability that the contestant received a score of 5 on day 2 or on day 3? The importance is, or means plus. Or means you add the probabilities. Add probabilities. It's important to note this because sometimes instead of the word or, you're going to see and. Or is saying either of these things could happen, and is saying both of these things have to happen. And with and, you would multiply your probabilities. So 5 out of 5 on day 2 or day 3, given that the contestant received a score of 5 on one of the 3 days. So that's important. Basically, it's saying the contestant only received a score of 5 out of 5 on one of the 3 days. If the contestant could have gotten a 5 out of 5 on multiple days, then we would have to account for not just day 2 and day 3, but also the combination of what about the times that the contestant scored both. So that makes things simple. Anyway, we know that our target is 2 plus 3 because of the word or. So our target is 2 plus 3, which is 5. And your target should be your numerator. With probability, here's another tip. You're going to have target divided by your total. And your total is going to be the total possible value in whatever category you're looking at. So in this case, because we're only looking at scoring a 5 out of 5, our total should only be the total for that column, 5 out of 5. And it actually gave us the total 7. So our denominator is 7, and our answer is 5 out of 7. Let's start with central ideas and details. Regardless of whether it's a detail question or a central idea question, you're going to want to start with the question so that you know if you're dealing with a detail versus a main or central idea. So here we look at the question. It says, what does the text most strongly suggest about Sleep No More's use of its performance space? So the keywords here for me are use of performance space. I'm going to assume that Sleep No More is sort of the subject of the paragraph, so that goes without saying. And because it's asking for something very specific, this is going to be a detail question, so I can sort of just skim through and look for that particular detail. So I'm skimming through and I see the word performance space, which is a 5-story warehouse turned into a 1930s hotel. But the question here is the use. So how is this space being used? It says audience members wander through at their own pace, interweaving loops, confront the impossibility of experiencing the production in its entirety. So the big thing that's standing out to me is you have such a huge, convoluted venue, and it's impossible to see the entire production because of how big it is and the way that things are playing out simultaneously. And I do recommend coming up with sort of an anticipation of what you think the answer would be, and taking into account the last sentence here, the refusal of narrative coherence. So this thing that they're doing on purpose relies on the venue's immense and intricate layout. So basically, this is a really unique play, but it can only take place in this special, bespoke environment that was created, the performance space. That would be my anticipation. Going through, the way of the choice of a New York City venue likely enabled the play's creators to experiment with the use of theatrical space in the way that venues from earlier productions could not. There was no mention of earlier productions, so that one's out. Audience members likely find the experience disappointing. There's no mention of how audience members reacted to it. You might assume that personally you would find it disappointing, but that would be an inference, and we're not being asked to make an inference here. The production's dependence on particular environment would likely make it difficult to reproduce in a different space. That's definitely implied. I'm going to keep that one because can you imagine trying to do this on just like a regular stage? Audience members who navigate the space accordingly, according to a recommended itinerary, will have a better grasp. So it doesn't mention any itinerary, and it's pretty clear that audience members aren't meant to have the full grasp of the play's narrative. That's sort of the point. So I would say the answer is C. All right, so another central ideas and details question. Here, when we look at the question, it says, states the main idea. So at least we know we're looking for the main idea before we go in. Not going to be quite as skimmable, and we don't know exactly what we're looking for, but we could always take a look at the first and last sentences. Those tend to be where main ideas live. But with a text this short, honestly, I would probably just skim through the whole thing and slow down when you feel you're encountering a main idea. And for me, immediately I see for centuries the widespread acknowledgement of the involvement of cerebellum, and then it sort of defines the cerebellum, so I'm going to ignore that, in coordinating motor controls in humans has hindered recognition. Okay. So for centuries, this seems like the main idea already. There's widespread acknowledgement that this part of the brain is all about motor control, and it has hindered the recognition of other possible functions. So because we think of the cerebellum as something that is involved in motor control, we haven't thought, oh, what else could it do in addition to that? And then we do see in the next sentence, research from the last 2 decades suggests that it also regulates emotional and social behavior. So I would say the main idea is recently we're seeing that the cerebellum does more than just motor control. The recent verification of a pathway between VTA and cerebellum confirms long suspected role in motor control. Okay, that is not true. It said for centuries we've known that it's involved in motor control. Recent advances have challenged widely accepted claims about the function of a pathway connecting these two. So the widespread understanding was that the cerebellum is involved in motor control, not that it has a connection to the VTA. So that one's out. Cerebellum has primarily been thought of to regulate motor functioning, yes. But in recent years, neuroscience researchers have been uncovering additional functions. Yes, that's pretty much my anticipation. Feeling really good about C. Let's just make sure that we can get rid of D. Technological limitations have historically hindered the study of the cerebellum. It doesn't say that there have been limitations that hinder the study of the cerebellum. So that is out. And our answer is C again. All right, let's move on to inferences. So inferences are pretty easily identifiable because you're going to be asked to complete the text, which means you're inferring what would come based on what came before. The strategy that I recommend is to read quickly. So I would recommend reading the whole thing, but at a nice quick pace, and then make an anticipation, if you can, what you think is going to be the ending to the paragraph. And then eliminate answers that either don't make sense or go beyond the text and are sort of, stretching beyond what's already on the page. I'll show you what I mean in a second here. So researchers found that disruptions to an enjoyable experience, like a short series of advertisements during a television show, often increase viewers' reported enjoyment. Interesting. So disruptions are increasing viewers' enjoyment. Suspecting that disruptors to an unpleasant experience would have the opposite effect, which is what I would think, the researchers had participants listen to construction noise for 30 minutes and anticipated that those whose listening experience was frequently interrupted with short breaks of silence would thus... Okay, so if an enjoyable experience becomes more enjoyable because of little breaks, I think it would make sense to assume that an unpleasant experience with breaks would make the experience even more unpleasant. So that's going to be my anticipation. Find the disruptors more irritating as time went on. More irritating, yes, but as time went on, no. Just more irritating than if you didn't have breaks, right? Rate the listening experience as more negative than those whose listening experience was uninterrupted. Yes. Let's just make sure we could eliminate C and D, but I like B a lot. Rate the experience of listening to construction noise as lasting for less time. No. Perceive the volume. No, nothing about the volume. So definitely going to be B here. So there you can see an anticipation worked really well. All right, let's look at one more of these. So same strategy. We're going to read quickly and try to come up with an anticipation if we can. Scientists studying Mars long thought the history of its crust was relatively simple. One reason for this is that geologic and climate data suggested by a spacecraft showed that the crust was largely composed of basalt, likely as a result of intensive volcanic activity that brought about a magma ocean which then cooled to form the planet's surface. So far, we thought the crust was simple because it's largely composed of basalt. And then it goes on to say the likely reason of it being mostly composed of basalt. A study led by Valerie focused on additional information. Further analysis collected. So this study focused on additional information. It goes to say what the study was, which is, more of a detail that we probably don't need to worry about. But what we do want to focus on is a study revealed that the presence of surprisingly high concentrations of silica in certain regions, since a planetary surface that formed in a mostly basaltic environment would be unlikely to contain large amounts of silica. Okay, so the big issue here is we think Mars's surface is simple because it's mostly basaltic, but then somebody found high concentrations of silica, which is unlikely in a mostly basaltic environment. So there needs to be some sort of a conclusion that says either Mars Mars's surface is not as basaltic as we thought, or that maybe the basalt was formed in a different way than it usually is. So maybe we'll need to focus on the volcanic activity, maybe some other way to get basalt other than that volcanic activity. So that's sort of my anticipation, but I'm going to start eliminating because I don't feel like I have a really great idea of what I'm looking for, but I know what I'm not looking for. The information about silica concentrations is likely more reliable than the silica information gleaned from infrared. Okay, no, that doesn't really make any sense. Doesn't talk about anything being unreliable, so I think that would kind of go beyond the text. There was no doubt cast on anything in the text, so A's out. High silica concentrations likely formed from a different process than by which form the crust of other planets. That sort of lines up with what I was saying, that either the way the basalt got there was a different process than we're used to, or I guess we could say the high concentrations of silica must have been from a different process, since it says a mostly basaltic environment would be unlikely to contain large amounts of silica. So like maybe the silica, I don't know, showed up after the fact or something. So I'm going to keep B for now. Having a clearer understanding of the composition of Mars' crust and the processes by which it formed will provide more insight into how Earth's crust was formed. Well, considering that we didn't talk about Earth at all, I would say C is definitely out. Mars' crust likely formed as a result of other major geological events in the addition to the cooling of a magma ocean. So we're right on the brink here. We have B talking about the high silica concentrations forming by a different process. And then D is talking about the entire crust forming in a different way in addition to the cooling of a magma ocean. Because we do have the specific mention of the magma ocean, and that's the process that is detailed, I would say D has to be our answer, because it doesn't really tell us how silica concentrations are usually formed. It just says that a mostly basaltic environment would be unlikely to have them. So because we only get details about that magma ocean, I would say our answer has to be D. And yeah, B is out. All right, let's look at command of evidence. So command of evidence, you're either going to have a graph-based question or you're going to have a text-based question. This first one has a graph. So it's going to be a graph-based question. And maybe this isn't the longest text, but because you also have to analyze a graph, it makes it a longer process. Regardless of whether it is a graph-based question or a text-based question, you're still going to want to just focus on the hypothesis or the claim, either weakening it or supporting it. So you're going to start with the question first, and this one wants us to weaken the hypothesis. All right, so we know we're weakening the hypothesis. What is the hypothesis? This is usually pretty easy to find. We look for the word hypothesis or claim or something like that. We see here a team of political scientists hypothesized that municipalities are much more likely to respond, so more likely to respond and offer incentives if expansions can be announced in time to benefit local officials than if they can't. So basically, announced in time would lead to more responses and incentives. We want to weaken that. And if we look at the graph here, we have announcement before the election, or we have announcement after the election. So in time would be before the election. So I'm thinking before election, we do not have more responses and incentives compared to after the election, basically, because that would be the opposite of what the hypothesis is. So if we look at the chart here, what I'm seeing is all three of these are pretty even. There's like a tiny bit more. If we zoom in, you can see before the election is a little bit higher, just like a tiny bit higher than after, but it doesn't seem significant enough. So something about that is what we're looking for, that it's not significant enough. Going back to our question here, large majority that received inquiry before the next election didn't respond. So it looks like that is true. Like most people just didn't respond at all, but that's true of both of them. So it doesn't really weaken the hypothesis at all. Remember, we're looking for an insignificant difference, basically. The proportion that responded or offered incentives didn't substantially differ across the announcement timing conditions. Yes, that's exactly what I said. Let's just get rid of C and D to be safe. Only around half of the municipalities that responded mentioning plans for an announcement before the next election offered incentives. That may also be true. I'm not even going to look though, because regardless of whether it's true, it doesn't match my anticipation. Of those that received an inquiry, more than 1,200 didn't respond. Again, it's not mentioning before versus after. So whether or not it's true in the graph, it's irrelevant as far as weakening the hypothesis goes. So it's going to have to be B. All right, now let's look at a text-based one. We're still going to do the same thing. This time, they're using the word claim, but again, it's pretty much the same as hypothesis. And this time, we're going to support the claim. So what is the claim? According to an arts journalist, so this sounds like it's a claim. Later in his career, this art historian sought to remedy this deficiency. Okay, so we do need to know what the deficiency is. What is the deficiency? Enwezer encountered few works by African artists. Few works by African artists. This is the deficiency. The claim is that Enwezer tried to fix this, not by focusing only on modern African artists, but by showing how their works fit into larger context of global modern art. Okay, so basically how African artists' works fit into the larger context. Basically just including them, incorporating them. So we're looking for something that shows that happening. As a curator of, not sure how to pronounce that, Enwezer organized a retrospective sculptor work entitled One of the Largest. Okay, so this says devoted to a Black artist. So it's not mentioning African art. It's just saying Black art. Even if it did say African art instead of Black art, I don't see the context with other works in global modern art and history. So I'm going to get rid of A. In the exhibition post-war, brought works by African artists. Okay, so we have works from African artists together with pieces by major figures from other countries. Okay, so we have African artists' works being brought together with works from other artists from different backgrounds. That seems to fit it in context with other modern art, so I like B. I'm going to keep B for now. And Wezer's work on this exhibition about independence and liberation in Africa showed how African movements for independence were profoundly influenced by work of African artists. So this is all about African artists and African independence from European colonial powers. So it's focused on one very specific thing and only African artists. So that doesn't put it in context with all the other art around the world. So C would also be out. And Wezer organized these exhibition African photographers, not to emphasize a particular aesthetic trend, but to demonstrate broad range of ways in which, okay, so again, this is focusing on African artists only. It's not putting them in context with other art from around the world. So I would get rid of D, and our answer has to be B. All right, let's look at text structure and purpose questions. So for these, you're always going to see the main purpose of the text is the most common part of the question stem. And with purpose, we're looking for something sort of matter of fact. It's not so much a main idea that might require a little bit deeper thinking. Purpose is just right there on the surface. It should be fairly obvious what the purpose is. And you're definitely going to want to read quickly through the entirety of the text. It's not quite skimming, but I would call it very fast reading that you can get away with as long as you know that you're looking for the purpose. Studying late 19th and early 20th century artifacts, archaeologists found that this is a finding, so this is important. Black women employed as farm workers utilized hook and eye closures to fasten their clothes at the waist, giving themselves a silhouette similar to the one that was popular in contemporary fashion and typically achieved through corsets. So I'm seeing Black women employed as farm workers were trying to look fashionable even at work. In my mind, I'm thinking just like the purpose is to show that, these women wanted to look good at work. Looking good being, following fashion trends of the time, basically. That's what I mean by look good. So that would be the main purpose. To describe an unexpected discovery that altered the view of rapidly. No, that's not what I said. To discuss research that investigated the ways in which black female farm workers used fashion to resist traditional gender ideals. No, it seems like they were embracing traditional gender ideals by trying to look, I guess, like feminine even at work. So that would be the opposite. To evaluate a scholarly work that offers explanations for the impact of urban fashion ideals. So this is interesting because it says the impact of fashion ideals on the workers. It says that they were trying to follow the fashion ideals, but doesn't seem like a huge impact. Doesn't say that it was a huge hindrance on the way that they got their job done or anything like that. So that one I'll keep, but I don't love it. Hopefully I love D. To summarize the findings of a study that explored factors influencing a fashion practice among black female farm workers and the... Okay, this is better. It is summarizing the findings, but there's not like any strong opinion one way or the other. It's just kind of showing us, hey, these particular women at this particular time wanted to follow fashion trends even at work. That is kind of a summary. It's just there on the surface. It's the purpose. It's not going beyond like C is going beyond and trying to, say that they were talking about an impact where it was really just sort of stating a fact. So we're going to go with D. And then the other type of text structure and purpose question that you're going to run into is the underlined sentence type question. So here we're focusing on the underlined sentence, but you can't get away with just focusing on the underlined sentence. You do need to think about the context. So I'm still going to recommend that you quickly read through the whole thing unless you feel like you have a good idea before you get to the end, which you might have noticed happened in the last one. All right, in Jane Austen's novel, an almost imperceptible smile from a potential suitor causes the protagonist to blush. Her embarrassment grows when she suspects he is aware of it. Okay, so the part that we're focusing on is in this Jane Austen novel, some guy smiles and causes a woman to blush, and she becomes more embarrassed as he becomes aware. This moment in which Fanny not only infers Henry's mental state through his gestures, but also infers that he is drawing inferences about her mental state, illustrates what literary scholar Butte calls deep intersubjectivity, a technique for representing interactions between consciousness. That's really looking into that moment quite a lot. Okay, so basically, I think the underlined portion is acting as an example of this literary technique. So I would say the function is, it's an example of this technique that's mentioned. It states a claim about Austen's skill. No, it's not really talking about skill. It's just talking about a specific technique. It advances an interpretation of a protagonist who is contrasted with protagonists from other novels. I don't think it mentions any other novels, and it doesn't talk about the technique. It describes a reoccurring theme in Austen's novels that is a focus of a literary scholar's analysis, summarized in the following sentence. Okay, so I could see like the technique being a theme, since it does say a technique, specifically a technique that the literary scholar finds in Austen's novels. Maybe it could be considered a theme. So I'll keep C for now. It provides a synopsis of an interaction that illustrates a literary concept discussed in the following sentence. Okay, literary concept. That sounds a lot more like a technique. You saw that I kind of had issue with the word theme there. And yeah, a theme is usually more, I don't know, something like, the underdog, or like humans versus nature, or, some sort of a reoccurring theme. It's more big picture, and it's within the novel. It's not a technique or a concept. So I'm going to have to go with D on this one because that lines up with technique. All right, let's finish off with cross-text connections. Cross-text connections are actually pretty simple. You're always going to want to simply boop the like button. Boop. Okay, for real though, cross-text connections take more time because you're dealing with two texts, right? I think the most efficient way of doing this, I think the most efficient way of approaching them is to simply come up with the main idea for each text and then address the question. So here the question says, we want to guess how text 2, so how would text 2 respond to the underlined portion of text 1? So here we got lucky. We get to focus specifically on this underlined portion. And I've had students find success going either way, either starting with the responder or starting with the text that's being responded to. I'm just going to start with the text that's being responded to in text 1. So fossils of this thing have been found in these caves, but assigning an age to the fossils is challenging because of the unreliable dating methods in this context. And then the unreliable dating methods are apparently stratigraphic dating. Dates cannot be reliably imputed from those nearby animal bones. Okay, so unreliable dating methods, specifically stratigraphic dating. So what would the researchers from text 2 say? Let's see. Archaeologists have new cosmogenic nuclide dating techniques. Ooh, okay, so there's new techniques, not the ones mentioned, so probably something to do with this. To reevaluate these fossils, the same ones mentioned in the same caves. Technique involves analyzing, I don't know what that means, but it's a new technique. The researchers assert, okay, this is important. This approach avoids potential for misdating associated with assigning ages, which is what text 1 was saying stratigraphic dating would have issues with. All right. Well, I would say basically they would probably respond by saying this new method is actually going to work just fine. So not to worry, text 1. They would emphasize the fact that the fossils may have been corrupted. No, that has nothing to do with what I said. They would contend that analysis of the bones were combined. No, that doesn't mention the new technique. They would argue that their techniques, okay, I'll assume that their techniques are these better techniques, are better suited than other methods to unique challenges. That sounds pretty good, so I'm going to keep C for now. They would claim that cosmogenic nuclide dating is reliable in the context because it is applied to the fossils directly. Okay, so this also sounds good because it's saying this is reliable because it's applied to the fossils directly. So let's just make sure, because I like the wording on this one better, but it says because it is applied to the fossils directly. Is that true? Let's see. This technique involves analyzing the breccia, the matrix of rock fragments surrounding the fossils. Okay, that was very tricky. The only reason that I have to get rid of D, even though I liked it specifically mentioning this dating instead of just saying their techniques, it's literally not applied to the fossils. It's applied to the surrounding fragments, the rock fragments around the fossils. So D is actually false, so I have to go with C, even though I don't like the wording quite as much. All right, let's look at one more of these cross-text connection ones. This one, not quite as sciencey, and here we're being asked how would text 1 respond to text 2. I'll do the same thing. I'll start with what text 1 is responding to. So I'm going to actually read text 2 first. Video game scholars face a major challenge in the industry's failure to consistently credit the artists, designers, other contributors. Without reliable record, questions about development can be difficult to answer. Accomplishments of all but its best known innovators can be difficult to trace. Okay. So the main idea here, issue with credits to all in gaming. Something like that, right? And then text 1 says, films, and remember, text 1 is going to respond to this. Films and television shows commonly include long list of credits. Credit sequences are not exciting, but they ensure everyone's contributions are acknowledged. Because they are highly standardized, film and television credits are also valuable. Okay, so text 2 is about gaming credits and how there's an issue. And then text 1 is kind of saying like films and television, even though it's really boring, they do a great job crediting everyone. So I'm thinking the response would be something like maybe try to come up with a standard similar to film and television. That could be a potential way to fix this, something like that. So by recommending that scholars mentioned in text 2 consider employing the methods regularly used by film and television researchers, that doesn't sound bad. Pointing out that credits have different intended purpose, no, I don't think so. By suggesting that they rely more heavily on credits as a source of information, that also doesn't really Makes sense. By observing that a widespread practice in film and television largely prevents the problem faced by the scholars mentioned in text 2. Okay, I like that one too. So we're down to A and D. A is saying recommending that they employ the methods used by film and television, whereas D is saying just observing that film and television prevent this sort of problem. This is hard because for me, I want to help and, fix things. So I would maybe recommend that we do something more like what film and television is doing. But we have to think about like the main idea of the text. Is it saying everyone gets credit in film and television and I approve of this, I recommend this to other industries? The text itself isn't really making a recommendation per se, so I think it needs to be a little bit less aggressive, not aggressive, a little bit less assertive, because A is inferring that text 1 wants to offer a solution, whereas D is just being like, hey, did you know that television that doesn't have this problem? And maybe let text 2 figure it out on their own. So I'm going to have to go with D. Just because it's a little bit more matter of fact, and that tends to be what we're looking for in the English section. Let's start with a verb question. How do we know it's a verb question? All of the answers are different verb phrases. And when we're looking at verb questions, we're either talking about subject-verb agreement or we're talking about tense. I can tell that this is a tense question because all of these are in a different tense. So the easiest way to go about these is to look at the context and try to find other verbs to make sure that you're in the same tense as the surrounding sentences. So if we go to the sentence right before this one, we see economists in India use, that's our verb, use an ease of living index. So we know that this is something that is still current. It's not like they used to use it. This is something they do use today. So if I'm looking for simple present tense, I would go with measures. This tool measures economic potential. And that's true. If it's used today, then it measures today. All right, let's look at another verb-based question. So this time we might be dealing with subject-verb agreement because we do have were and was, which are both simple past tense. And then we have simple present tense and present perfect tense. We might need a little bit more context here. But in general, if you have at least one matching pair, so because we have were and was, it's good to assume that you're dealing with subject-verb agreement. And what we can do is we can try testing the odd verb out. When I say odd verb out, I mean if 3 of them are plural, then we would choose the singular one. And if 3 of them were singular, we'd choose the plural one. The way we test this is using the word he or she or they. So would we say he are or they are? We'd say they are, right? And since they is plural, are, we could consider plural. Same thing with were. We'd say they were, they have been, but we would not say they was. We would say he was or she was, right? So I'm thinking was is probably the answer, but let's just double check and make sure. Again, the trick is to just choose the odd verb out. Her exhaustive chromosomal survey of plants in the Silent Valley was instrumental. Okay, so you're going to notice I skipped all this stuff. If you have a big ol' parenthetical like this, basically I recognize that we had a comma, an explanation of what the Silent Valley is, and then another comma. All that stuff is non-essential information, so we can skip through it. We could also think her survey of plants was instrumental in the government's decision. And that makes sense, right? Because a survey of plants is not they, it is a thing. We would say it. So technically, I guess we should say, he was, she was, it was, because a survey is a singular thing, aka it. It was, a survey was. Her survey was. So our answer is D. All right, this next one is going to deal with possession and apostrophes. I say possession because this version of there, for example, is to show plural possession, like it's their house. And this version of its is the same thing for an object or an animal, like the dog wagged its tail. So the dog possesses or owns the tail. Whereas here we have an apostrophe and then RE. So this is basically they are. And then this version of its would be it is. Concept here is possession versus contractions using apostrophes. And do you know which word is supposed to work here? So let's get into it. I'm going to see if I can get away with just reading the sentence with the blank space in it. The animal which lays eggs but also nurses. Okay, so here we're going to put the animal. We want a pronoun to replace the animal. Well, is the animal singular or plural? The animal, it's one animal, so it would be singular. So we're going to go with either C or D. And then would we say the animal which lays eggs but also nurses its young with milk? No. We would say it's young. It possesses or owns the young, the young meaning its children. So our answer is C. Let's do one more of these as well. So this one is in the same wheelhouse. We know because we see apostrophes, we see options with apostrophes before the S, after the S, no apostrophe, no S. So this is the same kind of question. And let's do the same thing. Let's just talk about all the different answers here. So moons with an apostrophe before the S, that is singular and possessive. So it means there's one moon and that moon owns something, like the moon's dark side or the moon's cow, because there's a cow on the moon. This second one with no apostrophe would just mean more than one moon. So there were several moons. And then the third one here, if you have an apostrophe after the S, that means it's plural and it's possessive. So we would have multiple moons that own something. So like the moon's planet, for example. If there were several moons orbiting a single planet, you could say that that planet is those moons' planet. And then finally, moon, I think you know what that means. It's just one moon. So let's actually look at the context here. And this time I'm not going to skip ahead because I'm assuming we'll need the context to figure out which one of these makes sense. Earth is not a perfect sphere due to the blank gravitational pull. All right. So if we're talking about Earth, hopefully you know that Earth only has one moon. And we call it the moon. So it should be singular. For that reason, we can get rid of B and C. And then it says the moon's gravitational pull. So would we want to say the moon gravitational pull or the moon's gravitational pull? Well, the gravitational pull does belong to the moon, so it would be A, the moon's gravitational pull. I saw one more of these and I just had to go in because this one's interesting. We've got a couple different words that may or may not have apostrophes. We've got the novel and we've got the poems. So let's do a quick look at this one as well. Slam poet Elizabeth Acevedo's debut novel, The Poet X, I'm going to get rid of the non-essential information again, is composed of. So basically, the novel, you could say the novel is composed of poems putatively written by the novel's protagonist. I also don't care about this part. All right, so my first question is, do the poems possess or own anything? Poems putatively written. This is not a noun. You cannot possess putatively, so we don't want possession, so we can get rid of B and C. And then, does the protagonist belong to the novel? Actually, it looks like it does, but do we have one or more than one novel? Let's see. Oh, we said the debut novel. So it's one novel. And if you remember, yeah, this would mean plural, so it can't be D. Our answer is going to be A, one novel. This next one, I'm going to go ahead and categorize as a pronoun question. The reason being, every answer is a different pronoun. And in case you're not sure what a pronoun is, it's a replacement for another noun. So instead of saying my lovely mother, I could say she. Instead of saying the squirrels, I could say they. Instead of saying the robot, I could say it. And then we could also use those for anything plural, like those robots over there. Technically, those is known as a demonstrative pronoun. You can kind of see how it operates a little bit differently because you might actually use it with the noun as well. Those squirrels, those robots. those angry children, but we don't need to worry about that. The main thing is we can tell that this is a pronoun-based question. So what do we want to do with a pronoun-based question? My recommendation is to find the original noun and match it. The original noun, known as the antecedent, is what we should be looking for. So we know that our underlined portion is here. Blank will even find faces in clouds. And if we go back, we notice that we have another one of those non-essential phrases sandwiched between two commas. So I'm going to ignore that. And then we get so much that, so there's no nouns there. The human brain is primed to recognize faces. All right, so now we need to figure out, is faces the original noun? Because that would be plural. Or is it the human brain? Well, what would make sense? Faces will even find faces in clouds? Probably not. The human brain will even find places in clouds? Yeah. So we know our original noun is the human brain, and the human brain is a singular thing, aka it. So our answer is C. Just for good measure, let's look at one more of these pronoun-based questions. Again, we've got different pronouns. We even have one in there, which is interesting. But let's try to find the original noun. This disparity can be explained in part by the fact that rivers such as the Mississippi expand and contract as blank sediment. Let's think about this. If we look at A, they accumulate sediment. So what's the thing that it would accumulate sediment? So starting from the underlined portion, as we go backwards, we have the first logical statement I've seen is rivers such as the Mississippi expand and contract as blank sediment. So if we're going to rename the noun that's taking the verb, what is the verb here? Well, we actually have two of them. We have expand and contract. Now, the Mississippi is given as an example, such as the Mississippi, but the main message here is rivers expand and contract. So our original noun is rivers. Rivers is plural, so we would go with they. They accumulate. All right, the last type of question we're going to cover here is known as misplaced modifiers. And if you're wondering what the heck that is, let me give you a quick example. So if we had a sentence like, putting on his socks, the dog surprised Billy when it bit him. This is a misplaced modifier. The reason is this first phrase, which is known as our modifier, is describing Billy, right? Because who is putting on his socks? Billy is. So the rule is that because Billy is putting on his socks, Billy should come right after the comma. But instead, the dog comes right after the comma. So in order to fix this, we would need something like putting on his socks, Billy was surprised when the dog bit him. So that's a very simple example of a misplaced modifier. Now, you might be wondering, how did I know I'm dealing with misplaced modifiers? Well, they're pretty easy to spot. At least I think they are. All the answer choices are going to have a different noun that starts them. And you can see that that's true. We have Rabinal Achi, we have Kichi Achi, we have the military leader, we have there was a military leader, so existential there. So these are all different nouns starting our answer choices. All we need to do is figure out where's the modifier, usually before a comma, and then who or what is the modifier about. So here we have our underlined portion, and then sure enough, there's the comma, which means everything before the comma should be our clue. Based on events that occurred when Rabinal was a city-state ruled by a king, based on events. So whatever starts our answer should be something that is based on events that occurred. So it's probably not a person, right? So let's figure out what's going on in context. Rabinal Achi is a pre-colonial Maya dance. Okay, so a dance could be based on events. So let's keep A, and then the military leader, that's a person, so it can't be C. There was a military leader. That's not going to work either. Kichi Achi, the military leader, again, that's a person, so We know that it's A, again, because a dance is the only thing that could be based on events that occurred. All right, let's do one more of these misplaced modifiers. This one is a little bit less obvious, I think, because we do have two surfaces, noun, but then we have reaching surbluricity, which is technically a noun, but it's like an action noun. It's known as a gerund because this is an activity. Then we have superlubricity, another noun. But then we also have when their CFO drops below 0, so not a noun. So that one's not quite following the theme. Anyway, let's follow the rule here. Remember, we're going to find our comma, and then whatever's described before the comma is what should come right after the comma. And you can see here we've got parentheses, which is a really easy way to spot that non-essential information that we can kind of ignore. A nearly frictionless state. Okay, so whatever comes after needs to be a nearly frictionless state. So a state of being. When is not a state of being, so immediately we're going to get rid of A. Two surfaces, not a state of being. Reaching superlubricity, not a state of being. That is an activity. Superlubricity, that sounds like it could definitely be a state of being. And if we look at the stuff I crossed out, as its name implies, extremely slippery. So, like lubricant is something slippery. So superlubricity would be a very lubricated state. That one definitely takes a little bit of word decoding as well. But if we just stick with crossing out those wrong answers, we can still get our correct answer. Our first rule is what I like to call the sandwich rule. And the sandwich rule is when we have non-essential information sandwiched between two dashes. For example, we could say something like, my brother started trying to arm wrestle everyone. This is a sentence on its own, but what if we said something like, my brother, who wasn't invited, started trying to arm wrestle everyone. Now we can see the sandwich rule in action. And you're noticing that right now I'm using two commas. This is because we can actually use two commas. We always have three options when we have this sort of non-essential sandwich. We have either commas, a set of parentheses, or, in this case, dashes. You are never going to have to decide between those options. There will only be one clear answer. So just remember, all three of those are options, but only one of them will actually exist in the answer choices. All right, so that's an example of that rule. And just to clarify, why do we know this is not essential? Because if we remove it from the sentence, it still makes sense. That's why I started with the sentence before adding the non-essential information. All right, rule number 2 is what I like to call the Kirby rule. Now, if you're not familiar with Kirby, Kirby is a Nintendo character that can suck up powers. Basically, it's this little pink monster and it sucks up enemies and it steals their powers. And just like Kirby, dashes suck up the power of other punctuation marks. So the Kirby rule is when a dash is used to replace another punctuation mark. And a dash can replace quite a lot. So technically rule number 1 is this rule because it is replacing commas or parentheses. It can also replace periods, semicolons, colons, and even an ellipsis. Ellipsis being the little ... The thing to remember is dashes are extremely versatile. They can pretty much do whatever they want as long as they're replacing some sort of punctuation, which in some ways can be confusing, but in other ways can be very helpful. And this actually sort of leads to rule number 3, which is when in doubt. And my when in doubt rule is if no other answer choice works, that is to say you've actually eliminated all the other answer choices, go with the dash, because chances are it's doing something that works that perhaps you're just not as familiar with. We'll come back to this in a second, but let's go back to the Kirby rule. The sandwich rule shows us how dashes can replace commas, but let's look at some other instances. Let's think about a period or a semicolon, which is basically separating two independent clauses. We could have a sentence like, I did 3 backflips wearing a blindfold. Nobody cared. So here, you could see we have 2 independent clauses. I did 3 backflips wearing a blindfold. That could be a sentence on its own. Nobody cared. That could be a sentence on its own. So we could very well have semicolon. We could have a period. But because of that, we can also have a dash. And this is totally a stylistic choice. But again, you're never going to have to decide between a dash, a semicolon, and a period. There's going to be one clear answer. All right, what would it look like if we were doing a colon? So if you saw our colon video, you'll know that colons are really good at cliffhangers. We could set something up like, we were all shocked at what happened next. Uncle Billy jumped into the pool with all his clothes on. So this is actually an example of a cliffhanger, because if we say we were all shocked at what happened next, we kind of want to know what happened next. So then we resolve the cliffhanger by talking about how Uncle Billy jumped into the pool with all his clothes on. Colon would work really well here. Because it's 2 independent clauses, semicolon could also work. A period could also work. And again, a dash could work. Another example of this that doesn't have 2 independent clauses could be something like, a single word came to mind, panic. Again, we have a bit of a cliffhanger here. So we could have a colon, or we could replace it with a dash. All right, one more. We'll look at a single comma being replaced by an M dash. Say Barb. There, that's a little bit better. Barb got into her car, drove to the ocean, got out, and threw her phone into the water. So why would we ever use a dash instead of a comma? Again, stylistically, you might want to do this if you are looking for a more dramatic or impactful pause. So I think throwing your phone into the water is sort of a dramatic thing to do. So for me, the dash makes sense. But again, I can't stress this enough. You'll never have to make a stylistic choice. You just need to know, is a dash capable of doing that? Yes or no? So you wouldn't have to decide between this or a comma, which would also work, or an ellipsis, right? Because we're wanting sort of a dramatic pause. And as far as when in doubt, I feel like we need to actually see some answer choices to exemplify this. So let's remember that when in doubt is sort of something we can lean back on. But the big rule we want to remember is the Kirby rule, because technically the sandwich rule is a Kirby rule. And technically the when in doubt rule should also be the Kirby rule. So this is really all we want to focus on as we work through some problems in the practice portion. I'll show you when in doubt can come in handy. All right, let's do a few practice problems here. This will give us a chance to recognize that Kirby rule where a dash is replacing some sort of punctuation, and it will also give us an opportunity to see when you don't want to choose the dash, because it sounds almost like you could just choose it every single time, but I'll show you why that's not the case. So here we have, with some 16,000 in attendance, the second world black. Okay, so I'm going to start by getting rid of this first part because we have an introductory phrase, and I like to simplify as much as possible to make things easy on myself. The second World Black and African Festival of Arts and Culture, or Festac 77, as the event was more commonly known, dash. Okay, so here, if we look at our dash option, it's pretty clear that it is creating that dash sandwich that we were talking about. So this one is definitely going to be B. And in this case, why would a comma not work? Because we talked about how you could also have a sandwich of commas, right? The only reason the comma is not going to work is because we're already ending with a dash. So even though we can use 2 commas, we can't mix and match. We need to either go with 2 commas, 2 dashes, or a set of parentheses, but no mixing and matching. It would be like making a sandwich, and one of your sandwich buns is like a nice sourdough bun, and then the bottom of your sandwich bun is, I don't know, a tortilla. It's not going to work out. All right, let's look at another one. In her book, The Woman Warrior. Okay, so again, I see that this is an introductory phrase. And the reason that it's easy for me to spot this is that you have a comma, and after the comma, we have our subject. So anytime you have something before the subject and then there's a comma, it means it's an introductory phrase. So we could basically start the sentence here. Author Maxine Hong Kingston examines themes of childhood, womanhood, and Chinese American identity by, and we could also sort of ignore anything after by, because more or less we know the sentence is going to end after that. All right? So, author Maxine Hong Kingston examines themes of childhood, womanhood, and Chinese American identity. Whoops, I didn't mean to get rid of identity. Well, just listening to that out loud, can you tell what's going on? We don't need any punctuation. So because we don't need any punctuation, that is to say, we don't need a colon, we don't need a comma, we don't need a period or a semicolon or anything, we also don't need a dash, because the Kirby rule, remember, is when the dash is replacing a punctuation mark. So if there wasn't any punctuation needed originally, we're not going to just add it for no reason. So our answer is B. And that's a great example of when you don't want to choose the dash as your answer, if there's no need for any punctuation that the dash could replace. All right, let's check out another one here. Let's talk about how we can simplify this. If you're doing sentence boundaries, you could actually ignore everything other than the sentence that contains the underlined portion. So I'm going to start here. The arrangement of the figures, according to Swenzel, represents her idea that we all come from the earth generation after generation. According to Swenzel. So what I'm noticing here is that we could get rid of according to Swenzel, and we could say the arrangement of the figures represents her idea that we all come from the earth generation after generation. So we have non-essential information, which means we have a sandwich going on, right? Sandwich can certainly be done with two dashes, but as we just discussed, we can't mix and match. Since we already have a comma starting the sandwich, we need a comma to end the sandwich. So our answer is going to be B. So there's another example of when you don't want to go with the dash. If there's a sandwich that's already been started by a comma or ended by a comma, or in the rare case that you see parentheses, parentheses. All right, this is the last question I wanted to look at because I think in a way it sort of exemplifies rule number 3 that when in doubt, a dash is going to work. Now for this one, we actually have dashes involved in all the answers no matter what. But let's just take a look at the way the dash is being used. I'm going to start with the main sentence, defying all odds, and we're going to get rid of that introductory phrase. Rudolph didn't just walk, she ran fast. So in every single answer choice, we have she ran fast, which is kind of crazy because normally we would just write she ran fast with no punctuation whatsoever. So here it would seem like all the answers are wrong. So then like what's the point of having a dash here? Well, let's think about it. We could do something like this, right? She ran fast, or maybe even she ran fast. It adds a little bit of emphasis to the fact that she's running fast by having a longer pause. An ellipse in this case almost like slows it down before the fast, which is weird. So it would make sense that a dash would be that long dramatic pause we're looking for. So here, the stylistic choice has already been made and it exists in all of the answer choices. So just wanted to show you because this one shows just how versatile a dash can be. Now with that in mind, let's look at our options and figure out what's going on here. So A is basically saying that we have one of those sandwiches, right? So how do we test that? Between the dashes, we should have non-essential information. We were just talking about how we kind of want to emphasize the word fast, so that doesn't seem likely, but let's just see what it sounds like. If we get rid of the word fast, we have Rudolph didn't just walk. She ran during the 1960 Summer Olympics in Rome. She won both the 100. Okay, so there's an issue there. The way that I just read it, we have a comma splice. That comma right there is separating two independent clauses if we read it the way that A claims it's going to go. So we would get rid of A. B, we run into the same problem. And I'm going to go ahead and get rid of this bit here as well. She ran fast during the 19 Summer Olympics in Rome. That's a weird one because I still feel like we have the comma splice, but then also instead of emphasizing fast, we're emphasizing fast during the 19 Summer Olympics in Rome. It doesn't roll off the tongue either. So B is not going to work again because we have a comma splice and because of the awkwardness I just mentioned. And then C, she ran fast, comma. During the 1960 Summer Olympics in Rome, she won both the 100 and 200 meter dashes and clinched first place. Okay, so here it sounds like we actually have a new sentence starting with the word during, right? So our first sentence is, she ran fast. New sentence. During the 1960 Summer Olympics in Rome, she won So because we have a new sentence starting with the word during, now this is a comma splice, which is no good. We need a period there or a semicolon there, which is exactly what we get with answer choice D. So D would be our answer. On this question, for example, we see that a period and a semicolon are both options, which is cool because they do the same thing and there's no other difference in the answers. So we know that we can eliminate both of them because you can't have two right answers. And real quick, see if you could figure out what the right answer is. Go ahead and pause the video. All right, the correct answer was D. Basically, everything before the word they is a big old introductory phrase. And we know this because they is the subject of the sentence. And anytime you have a subject coming after a comma, way later than the beginning of the sentence, most of the time that's going to be an introductory phrase. And then, of course, if we need a period like we do on this question, and you see that a period's not available, but a semicolon is, you're going to know that that's your answer. And just to clarify here, we have the island of Madagascar off the coast of Africa. So we can get rid of this to kind of simplify. The island of Madagascar is the habitat of more than 200,000 species of plants and animals, period. Many are not found anywhere else on the planet, period. So 2 full sentences, we want a period or a semicolon. And rule number 2, it's not quite as simple, but once you know what to look for, it's pretty easy to spot. To understand the second rule, it's important that you first understand the comma rule that it stems from. And you probably do because this is the most common comma rule. We use commas to separate items in a list. We can see that here pretty clearly. I need to buy 3 things at the store. Our first item is apples, so we get a comma. Second item is bananas, comma, and oranges. Pretty simple. But what if the sentence looked like this? I need to buy 3 things at the store. Apples, which are my favorite fruit, bananas, which are a great source of potassium, and oranges, which are packed with vitamin C. So here, we're using commas because that's the rule, right? And this is acceptable, but I think you would agree that it looks kind of wild because we have so many commas, it's hard to keep track of what's going on. So in this case, we can employ the second semicolon rule, which is you are allowed to use semicolons to separate items in a list if those items contain their own internal punctuation. So what do I mean by internal punctuation? Every item in this list has a comma already. So our first item is apples, comma, which are my favorite fruit. Because that comma is a part of the item itself, that counts as internal punctuation. Boom, change that to a semicolon. Our next item, bananas, which are a great source of potassium. That's our next item. Boom. And then and oranges, which are packed with vitamin C. We finished our sentence. So I hope that makes sense. Again, we're separating the items in a list and we're placing the semicolon at the end of each item, and each item has its own punctuation. More often than not, this is going to be a comma that you see. I'll give you one more example here. We've got the student council announced the themes for Spirit Week, Meme Monday, where everyone dances as their favorite internet meme. That's our first item. And here again, you see a comma, although technically we're also using quotation marks, which is internal punctuation, right? TikTok Tuesday, a day to recreate viral dance moves between classes, semicolon, because that was our second item. Whisker Wednesday, celebrating cats with attitude. Throwback Thursday, featuring music hits from the ancient era of the 2010s. And Futuristic Friday, where everyone dresses as if they're attending a concert in 2040. So hopefully that's starting to make sense. Let's put your understanding of this rule to the test by looking at an actual digital SAT question. So using the rule that we just discussed, pause the video and see if you could figure out the answer to this question. Obviously A has a semicolon. Are we going to end up using that semicolon or not? All right, I'm going to give you the answer. No, we actually do not want to use A here. Let's talk about why. So if you were thinking parentheses are punctuation marks, right? So that would count as internal punctuation. You would be right. We have the researchers analyzed gaze latency, how long it took the goats to look at the experimenter. So that's one big long item, right? And we do have internal punctuation. But there's already a comma here starting off the trend. Once we've started with a comma, we need to commit to using commas all the way through. So we could totally switch this out for a semicolon, and then we could go with A and have semicolons, throughout this whole list, but we're not allowed to mix and match. So it has to be C, even though we would be able to use semicolons in this case because of the parentheses. All right, let's just quickly go through a couple more to solidify this knowledge. Go ahead and pause and try to answer the questions yourself first, then I'll go ahead and explain. So we've got Charlie spun his guitar while playing and slapped the body of the instrument for a rhythmic effect. He even perfected startling tricks. And then I'm going to finish right there because we know that the sentence basically ends, right? He even perfected startling tricks like all this stuff. So we do have two full sentences, which means a period would work and a semicolon would work. Now, B has a semicolon, but we have the word and. Not only do we not want to use a coordinating conjunction when we're using a semicolon, we also don't have the word he, so B is very wrong. All right, this one we've got lightning bolts can be up to 5 times hotter than the surface of the sun. And all the answers are which is far hotter than the melting point of silica. And again, I can tell that the rest of this is just extra information being added to the end of the sentence. So I'm going to go ahead and stop there. In this case, we do not have two full sentences. The relative pronoun which cannot start a sentence. So in this case, we would want to eliminate choice B. And then what do we do if we have a relative pronoun that, adds on and ends the sentence with a dependent clause? We want to use a comma. So our answer should be C. Best practices would be to get rid of these other ones first with, logical rationale, but I was very confident on this one. All right, one more. Take a look. Each year, many species of shorebirds migrate from locations in the southern hemisphere to their breeding grounds in the Arctic, which is a journey of thousands of kilometers that requires frequent stops to fuel up. So in this case, we could go with either a journey or which is a journey, but our only option with which is has a semicolon. And as we just mentioned, which is going to be a relative pronoun. And let's follow best practices like I did not on the last one. Let's eliminate first. What was that rule that I showed you at the very beginning? We can't have a period and a semicolon because they both do the same thing. So we could eliminate both of these because you can't have two right answers. By process of elimination, we have to go with B. And we're actually going to start with rule 0, which is colons must come after an independent clause. An independent clause being something that can be a sentence all by itself. And to demonstrate this, let's actually use an example using rule number 1, which is the rule you're probably most familiar with. Rule 1 is colons can introduce a list. So an example of this might be, I have 3 pets. A dog, a cat, and a monkey. This works because I have 3 pets can be a sentence on its own. It acts as an independent clause, right? But if we have my favorite foods are beets, lettuce, and s'mores, this is not okay because we do not have a full independent clause. We can't say my favorite foods are and then just end with a period, right? So this is an incorrect use of a colon. We would not want this. I'm just going to leave this in red here to show you that this is not going to work. Moving on to rule number 2, colons can give an example. And I'll give you an example of colons giving an example. We'll say, my daughter is very sweet. She brings me home flowers every day. So here we have my daughter is sweet. This is a statement, and I'm backing it up with an example of something she does that's sweet. She brings me home flowers every day. And I also want to check to make sure this is a full independent clause. And yeah, we could say my daughter is very sweet, and that's a full sentence by itself, right? You know what? I'm going to stick this under rule 0. So that's an example. Rule 3 is that colons can resolve a cliffhanger. And let me give you an example of this. Let's say I said we all had the same thought in that moment. If I say we all had the same thought in that moment, you're probably wondering what was that thought. So I can resolve that cliffhanger with a colon and say, run! Right? So a cliffhanger would be something that leaves you hanging, right? You want to know what's going to happen next. So if I say we all have the same thought in that moment, you want to know what that thought was. And then I reveal that thought was run. And this actually shows off a cool feature about colons. Even though they must come after an independent clause, whatever comes after a colon doesn't need to be an independent clause. In fact, in this case, it's a single word, right? So it's kind of the wild, wild west. You could really have anything from a single word to a phrase to a full sentence after a colon, but before the colon, you need to have an independent clause. Now, believe it or not, those 3 rules are going to cover the vast majority of questions that you run into. There is a 4th one that I like to throw in there just because I've seen it a few times on the old SAT. I haven't seen it on the digital SAT yet, but it is that you can use colons to introduce a quote. And you might be wondering, why would I use a colon instead of a comma? Well, it goes back to rule 0. If you have an independent clause, something like, Dad hated the play. It was the worst. So now we're quoting Dad, who said it was the worst. Dad hated the play is a full independent clause. So because of that, we want to use a colon rather than a comma. Whereas if we said something like Dad said, then we would introduce it with a comma because Dad said cannot stand alone. So that's the difference there for you. And anyway, yeah, take a look at those 4 rules. Hopefully those examples make sense to you. And I tell you what, I'll put these rules in the description of this video as well. But, I would definitely take a screenshot. This is really, really all you're going to need to know to get through every colon that you encounter on the digital SAT. Let's actually look at some questions and see what these look like in context. So now let's take a look at some sentence boundaries questions and see if we could identify which rule is being used to justify the colon, or if the colon's not the correct answer. So I like to only focus on the sentence with the underlined portion, and I like to simplify the sentence as much as possible. So for example, in the past is an introductory phrase, we can get rid of that. I see a comma and a but, which means a coordinating conjunction. So we're basically starting a new sentence at the word in. So really I could start here and say, in 2017, a team led by Laura Wyrick of the Australian Centre for Ancient DNA, could even go with Laura tried something blank. The DNA found in Neanderthals fossils, dental plaque. So Laura tried something new, sequencing the DNA found in Neanderthals fossilized dental plaque. So if we do have a colon here, let's think about what's happening. First of all, rule 0, do we have a full independent clause? Laura tried something new, period. Yes, we do. So we're good in that regard. And then what does this sound like? If I say Laura tried something new, I bet you're wondering what she tried. So we have a cliffhanger. So good job if you guessed that one. All right, let's look at another one. So we've got the number of jams available for tasting varied. Let's try the one with the colon first. So first of all, do we have a full independent clause? The number of jams available for tasting varied, period. Yeah, that's fine. So rule 0 is good. And then what's happening here? Some shoppers had 24 different options, others only 6. See if you can guess what's going on here. Which one of our 4 rules? So I would say this is definitely an example. We make the statement that the number of jams available varied, and then we give the example that some only had 24 while others had 6. So that's an example of how they varied. And yep, that works. So in this one, we're going to want to actually do something before we read the sentence. We're going to want to go ahead and boop the like button. Okay, for real though, let's take a look. I'm going to get rid of this first part. The innovative works of Congolese sculptor and architect Bodies Isaac Kingeles Is that a full sentence on its own? No. So here you see how by checking rule 0, we can immediately get rid of the colon. And I guess we might as well go through and finish this. Since it's not a full sentence, obviously A is not going to work as well since that's basically a period there. And then we just have to figure out if we want a comma or not. So what's the subject of the sentence? The innovative works of Congolese sculptor and architect Bodies Isaac Kingles is the subject, and the main verb is were. We do not want to separate the main subject and its verb, so we're going to go with C, no punctuation. Let's take a look at this next one. So we have a group of ecologists, and I'm going to simplify here. A group of ecologists examined the defensive responses of 2 varieties of the sweet potato plant. Is that a full sentence? Yes. So we're good on rule 0, and already I'm identifying what's going on. If you want to take a second, try to guess which rule is actually going to give us D as the correct answer. 2 varieties, and then they list the 2 varieties. So yeah, this is to introduce a list. All right, let's do one more here. So we have researchers studying Magnus sensation have determined why some soil-dwelling roundworms in the southern hemisphere move in the opposite direction of Earth's magnetic field when searching for food. Is that a full sentence? Does that work by itself? Yes, it does. Rule 0 is checked off. And again, I'll let you take a look. Spoiler alert, we do have a colon working correctly here, but the question is why? Which one of our rules does this follow? So I would say this is a cliffhanger. They tell us that researchers have determined why this happens. So you might be asking yourself, okay, why? Then after the colon, it resolves the cliffhanger by telling us why. And just to reiterate, I haven't found rule 4 in action, so you really don't need to worry too much about that one. But if they do start implementing it, I wanted you guys to be prepared. But that's why there's no examples of rule number 4. First, you need to know how to deal with percent of. So here we see it says, this year the number of students enrolled is 140% of. What you need to remember is of means you multiply. So to get a percent of something, simply multiply by the number form of that percent. What do I mean when I say number form? So to turn a percent into a number, all we have to do is move our decimal place over to the left 2 spaces. So 147, that's our percent, right? And there's an invisible decimal here. If we move it over 2, we get 1.47. So move that decimal over. That's the number that's equivalent to 147%. It says last year, 200 students enrolled. So to get 147% of 200, we multiply 200 times 1.47. Plug that into your calculator, and our answer is 294. All right, let's look at one more of these, and I definitely encourage you to pause the video and try this one on your own first. This one's a little bit more challenging, but we can see it says 40% of, so we're dealing with that same concept. This one's just going to be a little bit more difficult. So it's telling us that there are 40% of items that are red. So basically, we have our total, and let's just call our total, I don't know, we'll call it X, right? X times, what would the percentage be? That's right, 0.4. So we could just say 0.4x. 0.4x of the items are red. And then of all the red items, 30% also have stripes. So this is where things can get a little bit challenging, because I was telling you, you want to take your original number and multiply by the number version of the percent. And we can certainly do that. All the answers are in percent. So we could literally just make up a number for X. And the easiest thing to do is to make our total 100. That way it's out of 100%, right? So basically 100, we'll say that's our total. And again, I'm just choosing this because it's easy to work with, times 0.4. Those items are going to be red, right? Multiply that together, it's going to be 40. Now here's the tricky part. Of the red items, 30% also have stripes. So it's not saying 30% of our 100 have stripes, it's saying of the red ones, 30% have stripes. So we take that number, 40, and we're going to multiply by 30%, which would be, that's right, 0.3. Plug that into the old calculator, and we do end up with 12. as our answer. And I do recommend just throwing in a real number. I feel like it's easier to conceptualize what's happening. But in case you wanted to know what it looked like if you didn't use a number, you could actually just multiply the percentages together, right? Basically, you want to say, what's 30%? Here, I'll change my color. What's 30% of 40%? You multiply 0.3 times 0.4, and you know that you're going to end up with 0.12 or 12%, right? So that's another way to get to your answer. The next concept you need to know is the percent change formula. And let me just start off by giving you that percent change formula. So the percent change formula goes like this. You have your difference divided by your original number. The two things that you need to remember are that the difference is the difference between the original number and the new number. And after you do this operation, you need to remember that your percent is in number form. So the decimal should go 2 spaces to the right to get back to percent form. Let's use this problem to practice. And by the way, the indicator that you should use this formula is a percent increase or a percent decrease. If they're asking you by what percent did it go up or by what percent did it go down. Here, they want to know what percent did it go up from 1960 to 1970. So if we look at 1960, we had 1. 1970, we had 1.6. Now, I said it's the difference, right? So the difference between 1 and 1.6 is 0.6. So in our numerator, we would have 0.6. And then the original was 1960, right? Because it's saying from 1960 to 1970. That means the original was 1960, which was 1. 0.6 divided by 1 is just still 0.6, right? And what percent is 0.6? If we move the decimal over 2 spaces, that is 60%. So there's the percent change formula. Let's look at one more of these. And again, I encourage you to try this by yourself first. A customer's monthly water bill was $75.74. So this is going to be our original, right? And we could already start setting it up. And just to identify, by what percent did the amount increase? So we know it's, an increase of percent. So our original $75.74. Due to a rate increase, her monthly bill is now $79.86. So remember, the top is going to be the difference. So 79.86 minus 75.74. And I don't know why I'm writing this out. Definitely just throw it in your calculator real quick, right? So that's 412, which means that's our numerator. Now do this operation in your calculator real quick. And the number should be 0.054. And remember, we want to move our decimal over 2 places. So if we go boop, boop, it would be 5.4%. All right, concept number 3 is how to add percent. Now, adding percent is very similar to finding a percent of, because remember, if we want a percent of something, we just multiply by that percent. The only difference is if we are adding percent, we are going to add 100% to whatever we're trying to add. Let me show you what I mean. Here it's saying the cost of a certain shirt is $20 before a 5 sale tax is added. And if you've ever paid for anything, you know that a tax makes a number bigger, right? You have to pay more. So this is adding 5% to 20. So if we wanted to get 5% of 20, remember we would do 20 times 0.05, right? But we don't want 5% of something. We want to add 5%. So what we want to do is add 100% to this number and multiply by 105% or 1.05. What's the logic behind this? That 100 is the original 100%, the original number 20. Because if we multiply 20 by 1, we're just going to get 20 again. But then we add the additional 5%. So again, you're just going to add a 1 or 100% to whatever number you're trying to add. And if we multiply those together, 20 times 1.05 is going to equal 21. So our answer is C. Let's look at one more here. This one is supposedly a little bit more challenging. So here we have the number n is increased by 6%. So n is getting multiplied by, what's the rule? Try and figure this out on your own first. Pause the video. All right, so we're going to multiply by 1.06. Our original 100% plus the 6% that we're adding. So basically, we can change this to 1.06n. And it says the result is 318. So let me just write that down here. 1.06n equals 318, and it's asking us what n is. Well, now we're just doing algebra, right? We're going to divide by 1.06, plug that into the calculator, and n equals 300. So that's how you add percent. All right, and the last skill you're going to need to know is how to subtract percentages. These are also pretty easy to spot because you're going to see something like lost a percent, or in this case, it says Thomas estimates each year the value of the stove will depreciate, aka go down by 20%. So the rule here is whatever they're asking you to lower the percent by, you're going to take that away from 100%, and then you're going to multiply by the result. Let me show you what I mean. So Thomas installed a new stove. Time of installation, the stove had a value of 800. So our original number is 800, right? And pop quiz, what would you do if you wanted 20% of 800? That's right, you'd multiply by 0.2. Another pop quiz, what if you wanted to add 20%? That's right, you'd multiply by 1.2. So what the heck do you do if you want to subtract 20%? Well, you take 100% and we're subtracting 20%. We're left with 80%, right? So that is actually the number that we want to multiply by, or I should say the percentage that we want to multiply by. Since 100 minus 20 is 80, we're going to multiply by 0.8. That's how we would subtract 20% from 800. But let's look at the rest of the question here. It says, what is the estimated value of the stove exactly 2 years after Thomas installed it, right? So we're not just going to multiply by 0.8 because that would be 1 year. We want to multiply by 0.8 twice. The first 0.8 is for the first year, and then there's another year that it depreciates after that. So we're going to multiply by 0.8 twice, throw that into the old calculator, and we get 512. All right, so that first subtraction example I showed you was already a medium difficulty. So let's do something a little different. We're jumping up to a hard difficulty level, and this problem is going to include 110% greater, so that's an increase of percent, and 55% less, which is a decrease. Go ahead and see if you could figure this one out utilizing both of those techniques. Pause the video real quick. All right, let's talk about it. So the number W is 110% greater than the number Z. So if we want to add 110%, what would that look like? Remember, we want to add 100%. So this actually becomes 210% or 2.1. So basically, W is equal to 2.1 Z. Because it is 110% greater than Z. It would take 2.1 Z's in order to make 1 W, right? Then it says the number Z is 55% less than 50. So if we want to subtract 55%, what's 100 minus 55? 45. So basically it would be 50 times 0.45. So Z is an actual number. Let's go ahead and get that number. 50 times 0.45 is 22.5. So I'll just rewrite that. Z equals 22.5. And then we can go ahead and substitute it over here as well. So instead of 2.1 times Z, we could have 2.1 times 22.5. And that's 47.25. And what were they wanting to know? What's the value of W? Oh, we accidentally just found the value of W. So our answer is 47.25. All right, in the xy plane, a line with equation 2y equals 4.5 intersects a parabola at exactly 1 point. Let's stop there. What does this mean for an equation to intersect a parabola at exactly 1 point? So let's think about a parabola. Basically, we have a couple of options most of the time. We either have a smiley face parabola, something like this, pretend it's beautiful, or we could have a frowny face parabola. Technically, we could also have a sideways parabola, but these are the standards, right? So what are the possibilities for a line intersecting these at 1 point? Well, let's think about it. And going back, it did say 2y equals 4.5. So if just saying y equals something, which means it's a perfectly straight horizontal line like this, that goes through 2 points, right? That goes through 0 points. The only way it's going to hit 1 point is if it goes exactly through the vertex. So this is going to be the only way that we get a line hitting only 1 point on a parabola. So anytime you see exactly 1 point, just remember we're thinking about the vertex of the parabola. All right, 1 point vertex. If the parabola has equation where b is a positive constant, what is the value of b? Okay, so we know that we're looking for b, and we know that we're looking at an intersection at the vertex. So let's go to Desmos and plug these in. All right, so I've plugged them both in, and if you're not familiar with Desmos, it's saying add slider b. So because we're using a constant here, anytime you use a letter other than x or y, it's going to ask you to add a slider, and a slider is basically going to let us choose a value for b. So here's the fun part. We can slide this around, and you're going to see that it affects our parabola, and we know that we want it to touch at only 1 point. So we want an intersection at the vertex like this, right? So here we have an option where it's working. B equals 6, okay? But it looked like there was also another option right here where it was working. B equals -6. So then how do we know what our answer is? Is it 6 or -6? There we go. B is a positive constant. So what is the value of B? It is 6. So just remember, whenever you are working with constants, if you are trying to determine that constant, you can pull up one of these sliders and then just slide around until you find what you're looking for. The circle above has center O. The length of arc ADC is 5 pi. Let's label that real quick. Definitely always going to recommend that you label your geometry or draw your geometry if they don't give you a picture. So ADC, that's going to be the small arc, right? So that's 5 pi right there. And x equals 100. So this guy right here is going to be 100 degrees. All right. So what's the length of ABC, which is the rest of the circle basically, right? So how the heck are we supposed to do this? Well, what do we know to be true about every circle in the known universe? That's correct. They all have 360 degrees. So it would be safe to say that this little fraction of the circle, this sector of the circle, is going to be 100 degrees out of 360 degrees, right? And here's something that's cool. Any central angle is going to make up the same proportion as the arc that it subtends. That is to say, if this is 100 out of 360 degrees, whatever that proportion is the same amount that 5 pi is compared to the rest of the circumference. Because an arc is basically a piece of the circumference, right? So what we can say is that this is equal to 5 pi out of the entire circumference. What are we going to do with this information? Well, we could certainly solve for circumference, and we could do that simply by cross multiplying here. And we do see pi in all the answers. So for that reason, I'm going to ignore the pi. All right. I don't want you to freak out. I'm ignoring the pi because pi is in all the answers. I'm also going to get rid of these zeros just to make things simple, which I'm totally allowed to do. Totally optional, but that's my preference. So first I'm cross multiplying 36 times 5. And just FYI, this is something that you can do whenever you have fractions equal to each other. You can cross multiply, aka you multiply the diagonals. could totally do this on your calculator, but 36 times 10 would be 360, so half of that would be 180. And then 10 times circumference equals 10 circumference. So basically, if we divide by 10, our circumference is going to be 18. Technically 18 pi, but we got rid of the pi, right? Okay, so this is our entire circumference. 18 is our circumference. And if we go to the answer choices, sure enough, 18 pi is one of the answers. But we got to be careful. This is a difficult problem, not only because you need to understand the concept behind how arcs and sectors work, but they also have a trick answer here. Because if we remember from the question, and I probably should have underlined this, always double check the main question. What is the length of arc ABC? We're not looking for the circumference, so C is not our answer. Our answer is going to be the circumference minus 5 pi, right? Because we want just the rest of the circle. So if we take our circumference 18 pi and we subtract the 5 pi, we're left with 13 pi, right? Or just, 13, because they all have pi in the answer. So our answer is actually going to be B. All right, here we've got equivalent expressions, and we also have constants involved, which for some students is really intimidating. And, just looking at this, it doesn't look like it's going to be a lot of fun. We're thinking maybe we have to FOIL everything out and then who knows what, right? So there is a way that we can deal with this using Desmos, but I think it's still going to be a pretty long and drawn out process. So I'm going to show you what I think is the best possible way to solve this type of problem, which is using matching. And what we're going to want to match is AB, and then whatever AB is affiliated with. Let me show you what I mean. I need to get AB to exist first. So looking at the left side, rather than FOIL out this whole thing, let's only FOIL out the part of it that would create AB. So when we multiply AX by negative BX, we're going to get negative ABX squared, right? So that's what I mean by extracting AB. We find where AB comes from on the left side. So that's where AB is going to come from. Now, I need to also extract anything else from the left side that will be times x squared. Because basically values that are acting as coefficients for the same degree are going to be equal to each other. Let me just show you a quick example. So if we had let's take this, and then this was equal to ax to the third minus bx squared minus 2x plus 12, we would know that a equals 20 because these guys are both being multiplied by x to the third, and b equals negative 9 because these guys are both being multiplied by x squared. That's always going to be true of equations. Those coefficients being multiplied by the same degree, whether it be x squared, x to the third, or nothing, right? We could also say instead of plus 12, we could have plus c. And we know that c equals 12 because it's not being multiplied by x at all. So those will always be equal to each other. Anyway, going back to the problem at hand, we need to find out what else from the left side is being multiplied by x squared. Again, we don't have to extract this whole thing. We don't have to FOIL it all out. We just have to figure out where would x squared come into place. X times x makes x squared. And then, of course, 5x squared times 3 would still result in an x squared, right? It would be 15x squared. So that's literally all we have to do for the left side. And on the right side, all we're going to do is pull out things that are being multiplied by x squared, aka negative 9x squared. So we're following here. We just have all of the x squareds basically. Why the x squareds? Because we want to know the value of AB, and that's what AB is being multiplied by. Okay, and from here we just solve. We're going to subtract 15x squared from both sides. Negative 9 minus 15, what is that? Negative 24. And then here things get really easy. We have two negative signs, so we can get rid of those and turn them into positive because we're basically just multiplying everything by negative 1. We have x squareds that can be eliminated because if we divide the whole thing by x squared, they disappear. And then AB equals 24, just like that. All right, we've got a bit of a word problem here. And with word problems, I'm going to recommend that you skip all the way to the main question so that we don't end up reading things that we don't need to read. So the main question, which of the following systems of inequalities represents the conditions described? Basically, which one of these equations is true based on the scenario that they're giving us? So instead of reading this whole thing, let's try to find some differences between our answers and then just check to see what's true. One of the first things that I'm noticing is our answers will either be less than or equal to 10 or greater than or equal to 10. So for less than or equal to, we're looking for some sort of language like no more than, right? And then for greater than or equal to 10, we would want at least, because greater than could be the least or it could be more than the least. So here it says Marissa needs to hire at least 10. So we know that it's going to be greater than or equal to. Here again, let me just write that down for you. Good one to remember. At least is going to equal greater than or equal to. So for that reason, we can eliminate A because it has the wrong one, and also D because it has the wrong one. Okay, let's do the same thing. Let's look at B and C. What are the differences? Well, going on down the line, these are both the same, so we don't want to look at that, but we can see that both X and Y are either going to be greater than or equal to, so we're looking for maybe at least, or again, if they're less than or equal to, we're looking for something like no more than, right? And I guess I could write that down too. And it does say that X is junior directors and Y is senior directors. So basically, we want to look for that language. Oh, and I do see it here. So at least 3 junior and at least 1 senior. So at least is again going to be this one, which is shown in answer choice B. So our answer has to be B. So this next one has a really cool trick. All you need to do is boop the like button. Boop. Okay, but for real, let's take a look at this one. So we have a table here, and you can certainly plug tables into Desmos, but right off the bat, I don't like the way this is looking because we have a constant here in the table, and then there's another constant here in one of these points. And I'm having a feeling that Desmos might not be that helpful for this one. So let's just try and figure out what's going on here. It says the y-intercept is going to be k minus 5, comma, b. So basically, there's a line that is represented by this table, and the y-intercept is going to be this crazy point that has 2 constants in it. How are we supposed to deal with this? Well, the fact that it's a y-intercept is super helpful because if we think about it, any y-intercept is going to be the place where a line crosses the y-axis, right? So here, the y-intercept is right here. If we look at another line, the y-intercept is right here. We could even do a third line, or boom, all right? There's the y-intercept right there. What do they all have in common? Because they cross the y-axis, the value of x is 0, right? This is at 0 for x. So we were actually given a hint here that this should be 0, so k minus 5 equals 0. And if k minus 5 equals 0, we can add 5 to both sides, and now we know k equals 5. All right, this is starting to look a little bit better. So we can change this. Instead of k13, it'll be 513. Instead of k plus 7, negative 15, it'll be 5 plus 7, which is 12. And now I'm feeling a lot better about this. From here, we can do a couple different things. If you want, you could use the slope formula to find the slope of this, because our basic formula for a line in slope-intercept form would be y equals mx plus b. We could use the slope formula to find m, and then we could plug in one of these points, solve for b that way. Or we could use Desmos and just plug it in. Let me show you both ways, just in case one of them is faster for you. So let's start with the way I said, where we're going to just find our slope and then plug it into that formula. If you're okay with it, I'm going to get rid of this stuff. And to find our slope, we want to do difference in y divided by difference in x. So often it's written as y2 minus y1 divided by x2 minus x1. And plugging in those y's, we would just take these two y's here. I'm going to start with the positive one. So 13 minus negative 15 is the same as plus 15 divided by, now I started with 13, so I need to make sure that I start with the 5 there, the corresponding x. 5 minus 12. 13 plus 15 is 28, I believe. And then 5 minus 12 is negative 7. 28 divided by 7 is 4, so negative 4 is our slope. So now we rewrite y equals mx plus b. We can change m to negative 4, so our formula is y equals negative 4x plus b. And then we just plug in one of these points. I'm going to go with 513 because it doesn't have a negative number, and that seems a little bit easier. So instead of y, we'll have 13. Instead of x, we'll have 5, and then we're going to solve for b. So negative 4 times 5 is negative 20. Add 20 to both sides. 13 plus 20 is 33, and that would mean that 33 equals b. So that's one way to do it. Alternatively, we can go to Desmos and we can just plug in a table. All you need to do is click on the plus sign up here, add table, and then we plug in our values. So we had 5, 13, 12, and negative 15. Whoops, negative 15. And right now, I see there's just a little point here. One thing you have to remember with tables is you need to adjust this. Click on the little gear sign, click on the dot here. You can change the color, which is, not super helpful, but what we can also do is click on lines, and boom, now we have a line. The problem is this is not going to the y-intercept. So let's add our y-intercept, x equals 0. And then what would y equal? Well, we know it's going to be somewhere up here, so we could say like 20. But now you see we have two different lines. But if we keep messing with it, if we say like 25, 30, 32, 33, boom, it lines up. So that's a way that you could do it with Desmos. You could also take this value and call it like a, right? And then just say a equals 1. And now we can slide a around until it gets to where we want it, basically so that this is a single line and they have the same slope, right? So that's another way to do it and get 33. For this type of question, I would honestly recommend the first method that I used. It's important for you to get used to the basics of y equals mx plus b, finding slope, things of that nature, because it's such an essential part of algebra, and it's going to serve you on the rest of the SAT as well. All right, so we've got a linear function here, and basically we're trying to choose the equation that lines up with whatever scenario is going on. So let's figure out what's happening here. A window repair specialist charges $220 for the first 2 hours of repair, plus an hourly fee for each additional hour. So we could think of this as kind of like a one-time fee of $220. So it would be like y equals mx plus $220. As long as we remember that x is going to equal the third hour, right? Third hour. Because those first 2 hours are the $220, and then after that, it's going to be the third hour and beyond. So that's one way that we could think about it. And then it says that the total cost for 5 hours for repair is $400. Let's go ahead and figure out what our equation would look like in that case. So the total would be 500, and that's going to equal, basically third hour and beyond. So 5 hours would be M3, because we're getting rid of those, and M3 is kind of weird, so I'm just going to say 3M if that's okay with you. 3M plus 220. We could subtract the 220. 500 minus 220 is 280. 280 divided by 3. That is not going to be a clean number. And why is that? Because it's not supposed to be 500. It's supposed to be 400. My bad. Okay, 400. So instead of 280, it should be 180. And of course, that's going to be a nice clean number of 60. So m equals 60. And then our equation becomes y equals 60x plus 220. But we got to be careful, because remember, we said that our equation was based on the third hour and beyond, but it's saying just the cost for hours, and it's asking for when x is already greater than or equal to 2. So we need to get rid of those first 2 hours from our total. And if each hour is 60, then 2 hours would be 120. So if we subtract 120, we get y equals 60x plus 100, which is actually our answer. Again, we had to make that adjustment because my original thought was we're only talking about the third hour and beyond being x, but here it's saying straight up the number of hours. Okay, so that's one way that we could go about this. However, I think we could also use Desmos. Let's see what happens if we plug some answers into Desmos. And we'll start with A. Just remember that f of x is basically y, so that's going to turn into y. So first answer was y equals 60x plus 100. Okay, so we have a line. How is the line going to help us? Well, we can double check to see if the point matches up, because they basically gave us a point. They said 5 hours of repair, so 5 equals x is $400. So we're looking, does the point 5, 400 exist on the line? If this point exists on the line, it should be our answer. So we're going to scroll out, and this is why you always want to have your calculator handy. All right, there's 400. And if we go to 400, look at that, 5, 400. So we know that A is our answer. So there's a much faster way of going about it. Now, we did get lucky because the answer happened to be A, but we could go through pretty quickly and eliminate these other ones as well. All right, we got a little bit of a word problem here. So let's start with the main question, aka the last question. How many seconds after the launch does the model estimate that the projectile will return to a height of 7 meters? Okay, so we're looking at time as our answer. So we have to think about time as being either an x value or a y value. Well, it says that there is a projectile. So there's a projectile being launched. It's telling us it's a quadratic function. So let's just kind of get in our heads what's going on here. If we thought about this on a graph, a quadratic is going to be a parabola, right? And anytime a projectile is being launched, it goes up into the air, and then it comes back down. So this is kind of what we're looking at. It also says it starts with an initial height of 7. So we could, say that our y-intercept here is 7. It's going up into the air, and we're trying to figure out not what the x-intercept is, but rather when does it get back to that height of, 7, right? Okay, so in a nutshell, that's what we're dealing with. So we need to start with some sort of equation. And for a parabola, we have 3 different options. We've got standard form, we've got factored form, and we've got vertex form. Here, they're telling us the maximum height, which would be the vertex, right? Because it's never going to go higher than this. They're also telling us when the maximum height happened. It happened 3 seconds after launch. So we know that our vertex is going to be 3, 51.1. So for that reason, I would say let's use vertex form. Vertex form is going to be y equals a x minus h squared plus k, where h is the x coordinate of the vertex and k is the y coordinate. So if we plug those in, y equals a times x minus 3 squared plus 51.1. So we already almost have a full equation here. The only thing that we're missing right now is our a value. So if we could somehow figure that out, we would be in really good shape. Is there a way that we could do that? Well, if we had a point to plug in for x and y, then we could solve for a. Do we have a point? Well, we kind of do. They told us that the initial height was 7, right? We know that the y-intercept is 7, and at the y-intercept, y would be 7, and x would be 0. So let's figure out what a is real quick. -3 squared is 9. So this changes to 9a plus 51.1. subtract 51.1, and I'm going to use my calculator for this. It'll be negative 44.1. I'm going to make some room for myself here. Divide that by 9. So A equals negative 4.9. All right, we're almost done. Let's just go over here and update our equation, because remember, initially it was y equals a times x minus 3 squared plus 51, but now we know that a is negative 4.9, so we're just going to plug that in, and definitely pause and go back if you need to. Replace a with negative 4.9, and then our final question here is how many seconds would be x for it to return to a height of 7 meters. So basically, when y equals 7, what is x? So we plug in 7 for y. 7 equals negative 4.9 x minus 3 squared plus 51.1. And to make things easy on ourselves, let's go ahead and plug this into Desmos. So all we have to do is plug in our equation. And I'm talking about our original equation without y plugged in. And then we're going to scroll out, and we're looking for y equals 7, right? So there's 7. And look at that, x equals 6. So our answer is 6. All right, so here we have a question about mean. And we want to probably start with the formula for mean, which is sum divided by total. The sum is the sum of all values, and the total is the total number of values. So what would this look like if we plugged it in with the information we have? Well, they said the mean score of 8 players, so 8 players is the total number of players, so that would be our total. The mean was 14.5, so that's going to replace the word mean. And the sum is our only unknown. And we might as well figure out what that is. Could come in handy, right? So if we multiply 14.5 times 8, let me use my calculator so I don't get myself into trouble here. 116. And that's pretty much everything there is to know about the first sentence. Moving on to the next sentence, if the highest individual score is removed, the mean score of the remaining 7 players becomes 12 points. Well, let's just write our equation again. The new equation has a total of 7 instead of a total of 8. The sum is still unknown. And the new average was, because mean is average, the new mean or average was 12. So we'll change this to 12. And then this one I think I could do in my head. 12 times 7, well, basically 7 times 10 would be 70. Add 14 to that, we get 84. And then it says that the highest individual score was removed in order to get down to this number. So basically, what's 116 minus 84? 116 minus 84. I don't feel like doing that in my head. I'm just going to plug it in my calculator real quick. And that's going to be 32. So our answer should be 32. Okay, so this next question is what I would call a nightmare. This is absolutely terrifying looking. I hate it. There's fractions, there's a constant. So let's try and figure out what's going on here. Main question says, if the system has no solution, what's the value of p? So let's start with that. No solution. What does no solution mean? No solution in the case of 2 lines means that they're never going to touch. So if we visualize this, let's say we got a line here and we got a line here. They're touching, right? So that would not work. We could have something like this where they're not touching, but if we keep going, eventually they're going to cross paths, right? So the only way to have no solution is if they never ever touch, aka they are parallel and have the same exact slope, all right? So always remember, no solutions for 2 linear equations. You want to think same slope. How does that help us here? Well, basically, we just have to figure out what value of p would give the bottom equation the same slope as the top equation. And that could still be a nightmare because, what I'm thinking is we put the top equation into y equals mx plus b, so we know the slope, and then we mess with the bottom equation to kind of figure out which value of p gives us that same slope, which is not fun. But you know what is fun? Doing a little cheat with Desmos, since we're allowed to use Desmos. So let's pull up Desmos and just plug these in. All right, so my first one was 3 over 2y minus 1 over 4x equals 2 over 3 minus 3 over 2y. Okay, there's one line. It does take a while to type in, but I promise you it's faster than doing it on paper. Okay, and then we have 1/2 x plus 3 over 2 equals py plus 9 over 2. And since we have a constant p that we're trying to figure out, we do have to add a slider. So add a slider. And now, remember what our goal is? We're trying to get the same slope. We're trying to make these guys parallel. So we basically want to play with this until they are parallel. So if we slide this around, we can see that when p equals 6, they are indeed parallel. So our answer is going to be 6. All right, we've got a geometry question here, specifically dealing with lines and angles within triangles, and we're trying to figure out what this unknown angle is over here. So the only information we're given is that RT and TU are congruent. So I'm going to signify that with a couple of little lines. Let me make these real small, because you know what? I'm going to zoom in, because I need to see exactly what's going on here, and to show you exactly what's going on here. All right, and TU are congruent. Why is that important? Well, if they are congruent, that means we have an isosceles triangle, and our angles are also going to be congruent. So I'm just going to signify here that these guys will also be congruent. So right off the bat, we can figure out what these angles are, because every triangle has 180 degrees. So then basically, if we subtract our 114, we're going to be left with the remaining degrees available for this triangle. And then if we cut those in half, we'll get the angle of R and U, right? So basically we could say like 180 minus 114 equals, 2x, or I shouldn't say x, because x is what we're looking for. We'll say 2y. And that is 66 equals 2y, so then y equals 33. Okay, so that was just to figure out, that this is 33, which I don't really care about, but more importantly, that R over here is 33. Okay, so I think that's one step closer. Now, if we can just figure out what this top angle is, then by process of elimination, we could subtract and figure out what our final angle is. Let's just play ring around the rosy here. What can we see? Well, if this is 114, then this angle, because it shares a line with it, is going to be 180 minus 114. Because these are, I can't remember the term for it, but basically if two angles share a straight line, they add up to 180. It's either supplementary or complementary angles. I can never remember those two. But yeah, that's the rule. Straight line is 180 degrees because it's half a circle, right? This would be a circle, 360. If we cut that circle in half, then it would only be 180. And we actually already calculated that, right? We did 180 minus 114 just a second ago, and that was 66. So we know that this is 66. Now we can figure out this angle down here, right? Because we know 180 minus 31 minus 66 is going to be whatever's left over is that angle, and that's going to be 83. And then these ones, I do remember the name of. Anytime you have this sort of hourglass thing going on, basically the angles that touch tips are called vertical angles, and vertical angles are congruent. So this will also be 83. So then the last ring around the rosy that we need to do is 180 minus 33 minus 83 equals x. Plug that into my calculator because I'm lazy like that. And that is going to be 61. So x equals 61. What? Come on, bro. Okay, I accidentally put in 86 instead of 83. And that equals 64. So x equals 64. Let's zoom out and hope that that's actually one of our answers. It is. Okay, yeah, so 64 is our answer there. Before we get started, let's make sure we're using the correct calculator. Go to desmos.com, go to Math Tools, so hit Test Practice, and then choose Assessment, and we want the digital SAT, right? Boom. So It tells us it is indeed the graphing calculator. We're using the same exact one that they use for the actual exam, so we're all good. Let's start with one that surprises most students. You can use Desmos for tables. So we're going to copy this table exactly as it's written. Here's what you need to do. Click this little plus button, choose table. And then from here, it's pretty self-explanatory. We just fill in the table. We have 6, we have 3, 0. So boom, we have a table, right? This is not super helpful right now because there's a constant in here and it's going to tell us, hey man, we don't know what the constant is. Try defining it. So all we have to do is say something like n equals 1. Now we've defined it. And you're also going to notice that we have a slider, so we can change our value of n if we want to. Right now, let's do a couple more things. Let's go to the settings. Let's change this to a line so we can actually see the line. And then if we do change n, you're going to notice that it doesn't really matter for this particular question because they're asking us what the slope is. And as you can see, the slope does not change regardless of where n is. So I'm just going to throw n wherever I want. And then how can we find the slope here? An easy thing would be just to throw in the answer choices and figure out which one matches. So let's do that real quick. First, we have negative 92 over 3, and I can just say y equals negative 92 over 3x, over 3x. And right off the bat, that's our answer, because you can see they're parallel, they have the same slope. But we could simply go through, copy this, paste this, and then change to the other answers if we wanted to test the other answers. So if it was like, I don't know, 6, see that's clearly not the slope. So there you go. That's how you can use Desmos for tables. But either way, we know our answer is going to be A, and using Desmos, we were quickly able to get through this problem, including a table and a constant at that. Pretty cool, right? Now there is another way to find the slope. We could alternatively put in the slope-intercept formula, y equals mx plus b. But we have to change a little bit. Instead of y, we need to put y1 to match the y1 up here in our table. And instead of equals, we're going to do this little squiggly guy. And then instead of x, we're going to do x1, so m x1 plus b. And then we get some weird looking stuff here, right? But if you're familiar with the slope-intercept form, you know that m is our slope and b is our y-intercept. So now we know our slope is negative 30.67. Now in this case, it ended up not helping us quite as much because our answers were in fraction form. So we would end up having to convert this into fraction form either way. So I honestly like just plugging the answers in real quick. I don't think it takes that long, but just wanted to show you this other way of going about it as well. Next up, we've got system of equations. And I would say this is probably the most common type of problem that you're going to encounter that Desmos is super helpful with. Now, this one doesn't look like a system of equations right off the bat. We only see one equation here, but you're going to notice we have two constants, and then we also have 2 points. So if we use both points and we plug those in for x and y, we end up with 2 equations. We have negative 2a minus 6k equals 6, and we have negative 3k equals 6. The 0, as soon as we multiply it by a, it's going to just become 0, so I just excluded that. And this one, because we don't have a, we could easily solve for k, use substitution, and get our answer that way. But let me show you how Desmos will also make this pretty easy. We're literally just going to plug these in. The only thing I'm going to change is instead of a and k, I'm going to change these to x and y. So let's say we're solving for x. So we'll make kx and we'll make a y. And as you can see, all I did was plug those in. Look at our dot here, and we're solving for x, right? Our answer is negative 2, the power of Desmos. Let's look at one more system of equations that looks a little bit scarier. At least it looks a little bit scarier to me. It says line L passes through point 0, 0 and is parallel to the line represented by this equation. If line L also passes through point 3D, what is the value of D? We know that it is parallel, so it's going to have the same exact slope, and we can start plugging in what we know. So we have y equals 8x plus 2. This is our reference line, remember? And then the other line is going to be y equals 8x because it has the same slope. And they told us it passes through point 0, 0, so we know our y-intercept is 0. And then 3D, so let's find out where x is 3. Again, the mouse is coming in handy. This time we're zooming in. I'm going to scroll way up for this one. 324. So our answer is 24. We can also use Desmos to simply find the equation that represents a line that's being described. So in this case, they're telling us about this line that has a slope of negative 1/3. So we can get rid of A and B because we do not have a slope of negative 1/3. And then between C and D, we just plug those in, find out which one goes through point 9, 10. So let's start with C. After I plug it in, you can see that the line is nowhere to be seen, which is why I think it's really important that you get used to using a mouse and that you bring a mouse, because you can simply scroll to zoom in and out, and then we're like, oh, there it is. And what was that point we're looking for again? Okay, so we're looking for 9, 10. So if we go to 9, all right, this is not going through 9, 10. This is going through 9, 7. So by process of elimination, we know our answer is the other one. I think it was 13, right? And sure enough, there's 9, 10. So our answer is D. Desmos is also fantastic for finding intercepts, y-intercepts or x-intercepts for linear equations, or in this case, we have this equation. Looking at it, it's not clear exactly what kind of equation it is right off the bat. Maybe it's exponential because we have a little x up here, right? But let's just go ahead and plug it in and see what it looks like. Just remember, we want to change f of x to y. All right, so I went ahead and plotted it, and it's asking us about the y-intercept. So let's just find the y-intercept. Hold on, let me scroll and zoom out. Looks like it's 14. It is indeed 14. Piece of cake. And it says difficulty 3. I beg to differ. With Desmos, these are very easy. We can also use Desmos to find minimum or maximum, which is basically just going to be the vertex of a parabola. Here it's asking for a minimum. So just remember, a minimum means that the vertex can only be so low. So if we have a graph, it means our parabola is facing up and it's never going to go higher than that point right there, yeah? And all we're going to do is plug in our equation. So this is our base equation, but it's telling us that the real equation we want is f of x plus 5. So all we're going to do is anytime there would normally be an x, we're going to substitute that with x plus 5. So in those two spaces right there. Let's do that in Desmos. All right, so I have my equation in here. I need to zoom out, it looks like. There it is. It's like, where are you? And then our minimum is our vertex. So going to be negative 13, 6. And then for what value of x? So since it was negative 13, 6, our x is negative 13. Again, says it's difficult, difficulty level 3, but with Desmos, not so much. One other really cool trick you can get Desmos to do is you can get it to boop the like button. Boop. Okay, for real though. You can also use Desmos to deal with inequalities. And as you may have guessed, all we're going to do is plug in these two inequalities. I've already written them down here. And an inequality, you will want to go down to the keypad here to type greater than, equal to, less than, equal to. And then I'll turn on the other one. And basically a solution is just going to be any place where both colors merge, right? So we're looking for that combination of red and green, aka this zone right here. Now, we can just go back and forth and look at the points in the answer choices and figure out, which one lies here. And I'd probably just do that. But if you really want to get fancy and take full advantage of Desmos, you can also plot those points. So you can see I've already written them here. If I turn them on, and we know that this one, 0, -1, is the only one that lies in that region that we're looking for. So our answer is D, 0, -1. Another really cool way to use Desmos that a lot of students don't know about is to just solve complicated equations with a single variable. So here we have some absolute values, we have x, but there's no y. So how are we going to use Desmos to get our solution? Well, we're going to set both sides equal to y. So we're going to say y equals the left side, and then we're going to say y equals the right side. So let me pull up Desmos, and we'll start with y equals 25, the right side. And then we have the left side here, so let me plug that in as well. So now all we have to do is find the positive solution, right? Because it said, what is the positive solution? So we scroll over here, and we're looking for that point right there. And are we solving for x or are we solving for y? Well, y didn't actually exist originally, so we're solving for x. Our answer is 9. How's that for a magic trick? Desmos is also great for a number of solutions. These are usually problems that show up with parabolas like we see here. One thing that you will want to do is move stuff over and set it equal to 0 like you normally would with parabolas. So we want to have basically like y equals and then the rest of the equation. So all I'm going to do is copy my x minus 1 squared, but then we're trying to get 0 on the other side. So this -4, we would actually just add 4, and then our 0 becomes y, right? So that's how we would want to put it in Desmos. And how many real solutions does it have? So solutions, remember, are x-intercepts. If we go to Desmos, I've already plotted it right here, and you can see that it's never going to touch the x-axis, so it has 0 solutions. And just like that, we know our answer is 0, and we can, again, laugh in the face of danger and laugh at this difficulty rating of 3 because that was so easy. I think the big thing is just knowing to get it in that form first, and then you're good. All right, this one looks pretty annoying. We've got a function, but Desmos can also deal with functions. So we're going to plug this function in to start. F of x equals x plus 7 over 4. And for this, you do want to make sure to add expression. Sometimes it won't accept your function otherwise. All right, so we got our function in. Now it's asking us what is f of 9 minus f of 1. Let's find out. F of 9, 2. We got our answer. So yep, you can evaluate functions as well. 2 is our answer. This next one's good if you're in a pinch, but I would recommend just getting better at the other types of strategies you can use for equivalent expressions. Like this one, for example, we should know right off the bat that this is a difference of squares, so it's going to be c. But just to prove a point, we could also plug this into Desmos. So here we've got x squared minus 5, multiply that by x minus square root of 5, and you'll see that we have the exact same parabola. So we know that they are equivalent. You can also find median and mean using Desmos pretty easily, although I would argue for the simpler versions of these questions like this one, you're probably just going to want to do it manually. Again, getting used to things like crossing out the biggest number, the smallest number, biggest, smallest, and then your median is 3. But you can see here, if you wanted to, you could also write median, parentheses, 2, 2, 2, 3, 4, 4, 11, and get it that way. But I think it's faster to just do it manually. Likewise, we could take this data set and find the mean by typing in mean. So those last two you might have noticed were things you can do with Desmos, but things I don't necessarily recommend doing. And to be honest, there are so many things that you could technically do with Desmos to help you on the digital SAT, but I'm not going to go over all those because in most cases, you're better off just using your handheld calculator or just taking care of it on scratch paper because it's faster. I do want to hit on one more technique that I think can be useful and that I would recommend using as a little bit of a shortcut, and that is graphing circles using Desmos. So as you've probably already guessed, we are simply going to plug this into Desmos. There it is. And in this case, it's asking us for the center of the circle. Normally, we would complete the square to get this in the proper form, so we could just get the center of the circle that way, but let's see if we can use Desmos to find it. So what we can do is we can go to the very top of the circle, and Desmos is actually going to choose this point to highlight because it's the very top of the circle. You'll notice we go over here, it'll also get the very right, and we could go ahead and mark that and mark that. So what we can do here is, since we're already on -10, -10, we can just count up, from -20 to 4. So basically, the diameter of this thing is going to be 24. So then the radius is going to have to be 12. So we could literally just count down 12 or count up 12. Let's do that. So -20, we go up 12 or subtract 12, we're going to end up at -8, right? Here, I'll just plot that. So it's -10, -8. Boom. And that should be the center of our circle. And by golly, that is one of our answer choices and the correct answer at that. So a little shortcut there for you. We'll start with some easy stuff. So first question, they're giving us some information saying that AB equals AC on this triangle. And right off the bat, we should identify that as isosceles. This is an isosceles triangle. So if you have two equal sides, it means you also have two equal angles at the bottom. And then it tells us that ABC, which is this angle here, is 67 degrees, which means angle C has to be 67 degrees. And then it wants to know the value of X, which is our leftover angle. We know there's 180 degrees in a triangle, and then we just have to subtract 67 times 2. See, what is that? 120, 134, which leaves us with 46. And indeed, there's an answer right there. Here's another easy one dealing with lines and angles. It's telling us that these two lines are parallel, which we can kind of tell visually, but you do need that proof. So this line and this line, it's telling us that Y is 20 degrees and Z is 60 degrees. You're always going to want to label anything they give you. What's the value of X? Well, in case you weren't aware, because these lines are parallel, they're essentially forming the same exact angles with this triangle. So if Y is 20, this angle over here is also going to be 20. Make sense? And because of that, we'll do the same thing. We'll start with 180. Time we're subtracting 60 and 20, which is 80, which means X is going to be 100. Let's do one more easy question. I like to always start with the main question. So it's saying, which of the following is closest to the height of the cherry tree? So we know that's our goal. The height of the cherry tree is what we're looking for. Now let's look at the context. So Washington Monument casts a shadow that's 300 feet long. So let's draw this out. This is going to be the monument, and then the shadow would go across the ground. So it would be like this, yeah? 300 feet long. So we've got a little bit of a triangle here. At the same time, nearby tree casts a shadow that is 16 feet long. So then we've got a tree, that's my tree, and this is only 16-foot shadow. But basically, because it's the same time of day, they're casting the same angle of shadow, and we're looking at two similar triangles. Similar triangles meaning they are different in size, but they have the same angles and they are proportional. Proportional meaning the small triangle here is 16 out of 300 of the big triangle. And since it's telling us that the Washington Monument is 555 feet tall, so basically this is 555, we're going to stick that in the denominator since the big triangle was in the denominator over here. And then we're trying to figure out what this is. So from here, we can just cross multiply. That's when we multiply our diagonals. So 300x equals 16 times 555. I am going to do the numbers on my calculator real quick. That becomes 300x equals 8880 divided by 300. X is going to equal 29.6. Which of these answers is closest to 29.6? 30. All right, on to three medium questions. The triangle, we're looking for the value of A. Basically, we've got two sides of a triangle. We need the third. Whenever this is the case, you could always look for Pythagorean triples. Like, is it a 3, 4, 5 triangle? Is it a 5, 12, 13? I'm not seeing that here. So we'll just go ahead and set it up using the Pythagorean theorem, being a squared plus b squared equals c squared. So for a squared, we'll actually just use a since it is one of the legs. Because remember, c needs to be the hypotenuse. And then b would be 6, because that's the other leg. Legs being the sides that are not the hypotenuse. And then 21 would be our hypotenuse, so that's C. And I'll write the model formula up here as well, so you know what I'm plugging stuff into. And I'm tempted to, turn 6 into 36 and everything, but take a look at the answer choices. It looks like 6 squared is intact for some of these answers. So let's keep 21 squared and 6 squared just as they are, and just say a squared equals 21 squared minus 6 squared. So that's just me subtracting 6 squared from both sides. And then to get a by itself, we would square root all that stuff. So 21 squared minus 6 squared. And is that an answer? Yeah, that's A. So that's our answer. Here's another isosceles triangle problem. We already talked about how this means there's two of the same side, right? And it's telling us that the measure of angle A is 50. So let's just imagine this thing. Let's pretend that I drew this really well and we're dealing with an isosceles triangle. And there's a couple different ways we could think about it because it's only telling us the measure of A. So either this could be A, so this could be 50 degrees, or these could both be 50 degrees. And I guess we could write the outcome if that were the case. So if these were both 50 degrees, we would have 180 minus 100, which means this would be 80 degrees. Call this our blue scenario. And then the pink scenario would be the top is 50 degrees. So we have 180 minus 50, that's 130 divided by 2. Both of these guys would have to be 65 degrees. So we got our pink scenario and our blue scenario. Again, just because it's not telling us which angle is A. So which of the following is not a possible measure of angle B? So we have in our chart here 80, we have in our chart 65, we have in our chart 50, which means the answer is D because that's the only thing that doesn't exist in either scenario. For the last medium difficulty question, we've got a circle question, which is rare. Usually these are difficult. So let's see. It's telling us that it has a radius of 5 and a center of -8, 6. So basically we know the equation for this circle, as long as you know what the circle formula is, which would be x minus h squared plus y minus k squared equals r squared. R is the radius, hk is the center of the circle. So if we plug that in, we would have x, because it's minus in our formula, we have to flip it, right? So if it's minus, then a negative becomes a positive becomes a negative. So, oh, and I should have mentioned h is the x value, k is the y value. So the x value is -8, which means x not -8, but +8, because we're flipping it, plus y minus 6 squared equals 5 squared, aka 25. All right, let's see if that exists. A is not it. X plus 8 squared, y minus 6 squared. Boom, it's B. Our first hard question here is also a circle question. And it looks like it gives us the equation. So we know a lot. We know that the radius is going to be 4 because 4 squared is 16. We know that the center of the circle is 6, -5. Again, because of that same circle equation that we just talked about in the last question. And it's telling us that there's a point on the circle, and it's telling us that PQ is a diameter of the circle. So I'm immediately thinking we could use like the distance formula, maybe the midpoint formula, something like that. But because we have Desmos, let's just visualize things with Desmos real quick and see if that gives us bearings, and maybe we can find a shortcut. So here's the circle that I just plugged in. And let's plug in that point they gave us as well. So that was 10, -5. So that's our P, right? And then it's asking us if we create a diameter, basically we go all the way across the circle in a straight line from this point, what would be Q? Well, we know that the center of the circle is -5, so it's going to have to stay on -5, right? So it's either going to be A or C. And if the radius is 4, the diameter is 8. So what's 10 minus 8? 10 minus 8 is 2. And we can just double check to make sure that that works. 2, -5 is the other point. And I'll be darned, look at that. It is also right there on the circle. And we know it goes through the center, -5, so it is indeed a diameter. So our answer is A. All right, this is listed as a difficult problem as well. And it looks like we're dealing with a rectangle, but it also says we're looking at the rectangle's diagonal, which means we're actually dealing with a triangle. Let me draw it for you and I'll show you what I mean. So we have a rectangle, and then a diagonal is basically a line that goes from one corner to the other. So that's our diagonal, and it's saying that the diagonal is 3 times the square root of 17. It's telling us the length of the shorter side is 3. And then it wants to know what is the length of the rectangle's longer side. So when it comes down to it, we're just looking at the Pythagorean theorem again. So let's write that formula. A squared plus b squared equals c squared. We're going to plug it in again. This time, we'll just say 3 is a, so 9, that's 3 squared, right? 3 squared is 9, plus b squared equals, and then 3 root 17 is our C. And I'm going to zoom in here actually so that we can get a better look. All right, remember all of this is squared. So let's unpack this real quick. So we can distribute this. These terms are being multiplied by each other, and we can distribute them to the power of 2. So let's do 3 squared is 9, and then the square root of 17 squared is, well, 17. So 9 times 17, I guess 10 times 17 would be 170. So then what's 170 minus 17? That would be 153. And then over here we still have b squared, we have 9. So let's subtract that 9. So then b squared equals 144. And that's actually a number that we should be familiar with, hopefully, right? If the square root of 144 is a gross number. So b, let me scroll down here, b equals 12. And yeah, that would be our answer, 12. All right, our last difficult question here is going to be a SOHCAHTOA question. That is sine, cosine, tangent. It's mentioning tangent, right? So let's just get our heads around this real quick. A refresher, SOHCAHTOA. SOHCAHTOA is going to represent fractions. Basically, so means if we're dealing with sine, then we're looking at opposite over adjacent, right? So the first letter is either sine, cosine, or tangent, and then the next 2 letters are a fraction, where the letter coming first is the numerator, and then the third letter is the denominator. So if we're looking at tangent, which we are, it would be tangent equals opposite over adjacent. So in general, that's what's going on. Now, here there's actually quite a useful shortcut. And I do like to visualize, so let's actually draw a triangle here. And we know it's a right triangle, so we're allowed to make it a right triangle. So we'll just say that's our triangle. There's the right angle. And it says the tangent of one of the angles. So we'll just arbitrarily choose one. I'm going to go with this one down here. The tangent is square root of 3 over 3. Opposite would be way over here. Opposite means across the street. So that's our numerator, square root of 3. And then adjacent is right next to it. And you might be thinking, well, these are both right next to it. But one of them is the hypotenuse, and we don't want the hypotenuse. So it's going to be the leg, this one down here, which would be 3. The shortcut is anytime you're talking about the tangent of an acute angle, the other acute angle is basically just going to have the reciprocal of that. So the rule is the reciprocal would be our answer, 3 over square root of 3, which is d, which will be our answer. But we could also just look and check to make sure that that's true. So if we were looking at this angle, opposite is 3, right, across the street. Sorry, that was a terrible arrow. Across the street, 3. And then adjacent is square root of 3. So our answer is D. Try to memorize that, but if you have to, just draw it out and you'll be good to go. So before we get started, we really need to talk about SOHCAHTOA. And SOHCAHTOA is going to be your bread and butter of trigonometry-based questions on the SAT. So we're going to use see what I did there? We're going to use so as our example to start. The first letter in each of these 3-letter groups is going to stand for either sine, cosine, or tangent. So the S is going to be sine, and then we have the letters O and H and A. O is going to stand for opposite, H is going to stand for hypotenuse, and A is going to stand for adjacent. So you take your first letter, either sine, cosine, or tangent, you say that it is equal to your first letter, remember O was opposite, divided by your second letter. Remember H is hypotenuse. And I'll remind you what the hypotenuse is in just a second if you forgot. So that would be the so, right? Let's talk about ca. So if you remember, C stands for cosine, And then the next step would be equals. And then we have A, which is adjacent, divided by, again, hypotenuse because of the H. And then TOA, remember T stands for tangent, equal to, next letter O, so we would have opposite divided by adjacent because we have an A. And this is the most important thing for you to memorize when it comes to trigonometry questions on the SAT. The SAT doesn't really get that in depth with trig, which is nice, but this is one thing you definitely want to know. All right, let's talk a little bit more about what this looks like on a triangle. So we're not going to do the problem yet. First, I just want to explain some things. Let's forget about what's being asked, and let's just focus on this angle. So angle X, if we wanted the sine of angle X, it would be opposite, and opposite means across the street. So our angle is in the corner, we go across the street, and whatever we're pointing at, that's our opposite. So in this case, it would be 16. Let me change colors here, actually. 16 divided by the hypotenuse. So a hypotenuse is going to be the longest side of a right triangle. The longest side of a right triangle. And if you aren't sure which one the longest side is, it's always going to be across the street from the 90-degree angle. So we've got our 90-degree angle here, across the street, we've got our hypotenuse. So that's 23, right? So that would be 16 over 23. What if we wanted to know the cosine of X? Well, we go here, it says cosine would be adjacent divided by hypotenuse. Adjacent means right next to. So our corner's here, and obviously there's two sides right next to it. There's this one and there's this one. But what adjacent means is the one that's next to it that is not the hypotenuse. So it would just be this side here, which we don't know. So we're just going to call this, we'll call this Z, just for fun. So then cosine would end up being adjacent, Z, divided by hypotenuse. We already know the hypotenuse is 23, right? And then the last one, tangent, again, just looking at this angle X, where's opposite? We already defined that as 16, divided by adjacent. We know that adjacent, whoops, I forgot my label. Adjacent we were calling Z, so that would be 16 divided by Z. So that's an example of what all of these would look like. And again, I was just using it for this angle. If we were to be looking at the other acute angle, acute being less than 90, this one over here, then things would change, right? Opposite would now become this. Adjacent would now become this. The only thing that remains the same is the hypotenuse. So hope that clarifies SOHCAHTOA for you. Now let's use it to actually get our answer. In the triangle shown, what is the value of sine of X? Well, we already did the work, right? We determined that sine of X was 16 over 23. So that should be our answer, and we could actually move on. All right, for this next one, I definitely want you to give it a go. Try and do this one on your own first before I share the answer. I've written SOHCAHTOA letters up there for you, so pause the video and see if you can get the answer. And I want to see if you can get the answer without actually writing anything down, just as a little challenge. All right, so let's talk about it. It's asking for tangent of A. Tangent means opposite over adjacent, and it's the tangent of A. So looking at A, opposite is 20, adjacent is 21, so it should be 20 over 21, C. All right, let's bring this up to a new level here. This one, we do not get a picture, so I think that makes it a little bit more challenging. They're asking us about similar triangles, so we also need to know what those are. And just to give you a refresher, a similar triangle or two similar triangles are triangles that share the same angles, which means they are proportional. So we can talk more about that as we work through this problem. So it's saying there's triangle ABC, and it's going to be similar to triangle DEF. And then it tells us how they correspond. We'll go over that after we draw them. It's also telling us that the length of one of the sides of the first triangle is 2.9 times the length of the other one. Let's just start drawing these out first. We know that they're both right triangles because it does say, they both have right angles, and angles C and F should be at our right angles. So I'm going to say, forget what these angles are. We're just drawing to draw. Okay, so we've got a right triangle here, and I'll go ahead and label this, making sure that C is our right angle. And we'll just put A up here. And to be clear, A and B can switch places. I'm just deciding to put them here, but it doesn't really matter as long as they match up with the other triangle. Speaking of which, let's draw our other triangle. We'll change its color just to, and this one's going to be bigger, remember. So just to visually make ourselves happy, we're going to make this one bigger. And even though they don't have the same angles the way I drew them, we're going to pretend they do, right? So let's make sure that everything corresponds correctly. They said A corresponds to D. So this is going to be D since it's A on the other one. F is the right angle, so F is down here. And that leaves us with E, which is going to be over here. Cool. It's also telling us that basically this whole triangle is 2.9 times bigger, but I don't know if we're going to care about that because it's asking us about SOHCAHTOA, right? It's asking us about the tangent of one of these, which means we're really just worried about angles. Basically, if the tangent of A is 21, so I'm just going to erase this because I don't want us to get distracted here. We really don't care that much about this. Hold on, let me make sure we can actually see the whole triangle I drew. Sorry about that. What it's telling us that we do care about is that the tangent of A is 21 over 20. So tangent of A, remember tangent, and I didn't write SOHCAHTOA this time, so see if you haven't memorized yet. Tangent is TOA, opposite, so opposite is 21, divided by adjacent, TOA, 20. So that ratio is going to stay the same on our other triangle. So even though FE is technically 21 times 2.9, the ratio is still going to be 20 to 21, right? When it asks us the value of sine of D, we can still use these numbers. So sine, so opposite over hypotenuse, so it would be 21 divided by hypotenuse, which we don't know. So it's 21 divided by the unknown side. Now, if you know your Pythagorean triples, you're going to know that 20, 21, 29 is a common Pythagorean triple. So our answer would be 21 over 29. If you don't have that memorized, which a lot of you probably won't, we just use the Pythagorean theorem. So what would that look like? Let me grab a new color. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Just remember that A and B are your legs and C is your hypotenuse. So we could say 20 squared plus 21 squared equals C squared. I'm not going to do the math right now, but if you calculate that, you will indeed get 29 as your answer. So there you go. All right, we've got another one that includes a drawing here. Again, I recommend that you pause the video and try and solve this on your own first, but I'm going to go ahead and solve it. So it's telling us that sine of B is 5 over 13. So let's take a look here. We've got B. Remember, sine is so, opposite over hypotenuse. So opposite, they're saying, is 5. And then hypotenuse, they're saying, is 13. And I know what you're thinking. What the heck, man? It says that this is 26. So remember the last problem where I said the ratio is going to be the same? The ratio is going to be the same. We know that the ratio is 5 over 13, but if the actual side is 26, then we just have to think, well, how does that relate to 13? It's twice 13. It's 13 times 2, right? So basically, if this is 26, which is 2 times 13, the actual length of AC should be 10, right? So just to clarify, the ratio is 5 over 13, but because the actual side is 26, we could think of it like 5 over 13 is equal to what over 26? You could cross multiply, or again, you could just kind of see that that's 13 times 2. So then you get 10. All right, so I hope that's clear. Now, what is it actually asking us? It's asking us what's the side length of BC. That's the one that we don't know. Well, again, we have a Pythagorean triple. And here's another tip for you. Memorize some of your basic Pythagorean triples. In particular, I would really memorize the 3, 4, 5 triangle. So that's a Pythagorean triple. Probably the most common that's going to show up on the SAT. We talked about the 20, 21, 29 in the last problem. And then this one is another example, which is a 5, 12, 13. And just like the last one, if you don't have that memorized, you would again use the Pythagorean theorem, a squared plus b squared equals c squared. In this case, one of our legs is 10, the other leg is unknown, and then the hypotenuse is 26. So you could either do it that way, or like I said, you know that it's a 5, 12, 13. So your number is 12, but then you have to multiply by 2 since everything else is being multiplied by 2. So then your answer should be 24. That's the actual side length here is 24. All right, let's do one more of these. One last time, I want you to try this one on your own first, using everything that we have learned so far, but let me go ahead and work through it. So again, we have similar triangles, which you should remember from one of the other problems means they have the same angles. So again, I'm going to do a quick sketch of these just to help myself visualize what's going on. And it says we have ABC. Does it tell us the right angle? C and F are right angles. Okay, so C, F. I'll do the opposite this time just to show you that that's possible. A, B. A responds to D. So that means D is here. E has to be up here. Cool. Tangent of A. Remember, TOA is opposite over adjacent. So basically, this is the square root of 3. So far, we've been able to just use a fraction to get our sides, but they're not giving us a fraction. So what the heck are we supposed to do? Well, we need to figure out what the square root of 3 looks like as a fraction. So what we can do is take the square root of 3 and we can multiply it by 1, right? Because that way we're not changing it. So what would that look like? Well, remember, we're trying to aim for a fraction. So we could just do 1 divided by 1, right? And that equals the square root of 3 divided by 1. So we didn't necessarily need to go through that process, but if you ever just get a whole number, remember that the number they give you is going to be the first side, and then your other side is just going to be 1, because anything divided by 1 is itself. So even though they gave us a whole number, we can simply say the square root of 3, and then we can call CA 1. Boom. Hope that makes sense. All right, and then it's telling us that DF equals 125. DF equals 125. And it's asking us the length of DE. The ratio from CA to BC is 1 to the square root of 3. So we could say 1 over the square root of 3. And this should be equal, because remember they're similar triangles, to, instead of 1, we have 125 over our unknown, which is EF. We'll just call that X. And my favorite thing to do in this situation is just cross multiply. So 1 times X is X. And then 125 times the square root of 3 is 125 root 3. And you are going to see in all the answer choices that we have, the square roots are not resolved. So we're going to leave that as is for now. So 125 root 3. And here's where things get interesting. So the way I drew these triangles is actually not accurate now that we're seeing the lengths, because the square root of 3 is going to be bigger than 1, right? Because if you think about it, the square root of 2 is 2, which is bigger than 1. So the square root of 3 is definitely going to be bigger than 1. So in truth, these should be our longer sides. And as soon as we saw 1 and then root 3, if you have your special right triangles memorized, you're going to recognize that this is a case, and I'll actually draw the triangle the proper way. So it would look more like this, where we have our short side is x, our hypotenuse is 2x, and our other leg is x times the square root of 3. Lucky for you, this is included in that reference cheat sheet, so you don't need to have this memorized per se, but it is good to remember that it exists so that when you encounter something like this, you go to the cheat sheet. So if we follow these rules, our short side, remember, I drew it wrong. So our short side is actually 125. Our short side is actually 1, which means our hypotenuse is going to be 1 times 2 for this one. So this, we know our hypotenuse is actually 2. And this would be 125 times 2, which is 250. So our answer is D, 250. All right, we're going to start with some craft and structure because Rodrigo Flores requested it, and I'm happy to help Rodrigo. So, words in context. The following text is from, I'm not going to read this. I'm going to go straight to the question. What does the word trace mean in the question? So, I'm going to find the word trace. It's underlined for me. And we have supper time. Foxfoot would allow no fire to be built, no landing to be made, no trace of their passing to be left. For these types of questions, words in context, it is best to come up with your own answer first. So based on this, it sounds like this Foxfoot character doesn't want anyone to know where they are. So I'm thinking no trace would mean no signs that they were there. That'll be my anticipation. No signs that they were there. If we get down here, we've got evidence. Sounds great. Blemish? No. Amount? Certainly not. Sketch? No. So, boom. Evidence. Why? Because it totally matches what I just said with my anticipation, that there's no signs that they were there, no evidence that they were there. Okay, so this one starts with this is because, so I do need to read the first sentence. Many ancient cultures of people's heads are missing their noses. This is because the nose is the most blank part of a sculpture. Okay. So why would they be missing is the question. Whatever this is should answer that. I'm thinking that since they're ancient sculptures, they probably broke off because they were weak. So I'm going to say the most delicate or the weakest is my anticipation. Recognizable? No. Fragile? Totally matches. Common? No. Sophisticated? No. Boom. Fragile. Let's do some potentially more challenging ones here. Which choice completes the text? Okay, the works of Chicana artist Esther Hernandez are now blank in museums both in the United States and abroad, but the murals she contributed as a member of Las Mujeres Muralistas early in her artistic career were displayed in outdoor public spaces across San Francisco. But, so I'm going to use that but to come up with what would come before it, because we're trying to contrast with our answer basically. So we want it to contrast with outdoor public spaces across San Francisco are now blank in museums, both United States and abroad. Oh, okay. So outdoor would contrast with just being featured in those museums. So I'm going to think like, oh, well, normally I would eliminate, but I literally see the word featured. That's my answer. All right. And this one, we do have a really long sentence starting at the beginning. So I do have to read through. Whether Carmen Lomas Garza is creating small paintings and illustrations or large public artworks, I'm going to not read this because whenever you see those two dashes, that means this is basically extra detail, non-essential information. So I'm going to ignore it just to get a better idea of what's going on. So basically, when she's creating small paintings or large artworks, she is blank direct experience. Drawing from memories of her childhood in Texas or details. So she is blank direct experience. So if she's drawing from her memories, what is she doing with direct experience? She's using it. She's drawing from her direct experiences. So I'm just going to say she's using or incorporating direct experience. Complemented by, not quite, but I'll keep it around. Uncertain about, no. Unbothered by, no. Inspired by, yes. When I said she's drawing from, she's using, she is inspired by direct experience. Animal researcher Amalia P.M. Bastos led a 2021 study about a wild key parrot that used small stones as tools to preen its feathers. Well, that's cool. Skeptical colleagues had initially suggested Bastos that the key's interaction with the stones might simply be blank. Okay, so basically they're skeptical, so they think that maybe the parrot is not actually using the stones as tools. I would say might simply be an accident or might simply be a coincidence. And I'm going to stop reading there because I think I'm good. Intriguing, certainly, but not what we're looking for. Obvious, no. Accidental, yeah. Observable, no. Mary Engel Pennington, a chemist who helped advance home refrigeration, undoubtedly made a substantial impact on society, but her place in our historical memory is perhaps more blank than that of Stephanie Kwolek, who invented the incredibly strong material known as Kevlar, an accomplishment for which she will long be remembered. Okay, this is tough. It's saying that Mary made substantial impact, but her place is more blank than this other person who will long be remembered. So I want a word that means not well remembered. Her place in historical memory is perhaps more, I don't know, I'm going to say like subtle. So we have permanent, no, that's kind of the opposite. Let's actually play a game. Let's say I don't know what tentative means. What do you do when you come across a word that you don't know? Leave it there and eliminate first. So warranted, I know is like it should be happening. So I would get rid of that one. Prominent is obvious, the opposite of subtle, which was my anticipation. So I would get rid of prominent. If you're able to eliminate all the other answers, you can choose the one you don't know. Unfortunately, if you end up with two words you don't know, or you end up with two answers at that point, then you're just going to have to make your best guess if you're not sure what either word means. And in case I forgot to mention it, tentative means like unsure. When you make a tentative plan, you're like, oh yeah, let's tentatively plan to meet up on Friday, but we're not sure if we're actually going to meet up on Friday just yet. All right, next up, we're going to do some structure and purpose questions, starting with number 6 here. So, which states the main purpose of the text? And for these types of questions, I do like to read the whole thing and again, come up with my own answer first. The following text is adapted from Gene Webster's 1912 novel, Daddy Longlegs. That's a fun title. The narrator is a young college student writing letters detailing her weekly experiences. The college is organizing the freshman basketball team, and there's just a chance that I shall make it. I'm little, of course, but terribly quick and wiry and tough. While the others are hopping about in the air, I can dodge under their feet and grab the ball. So the main purpose, well, it says that the college student is writing letters detailing her weekly experiences. So it doesn't sound like she's writing to someone, but rather for herself. I think the purpose is just to reflect on why she thinks she might actually be good on the basketball team. So to compare basketball with other sports, no. To provide details how to play, no. To state how players will be chosen, no. To explain why she thinks she might make the basketball team. That's literally what I just said. So, boom. All right, so we have another main purpose. In the late 1800s, Spanish language newspapers flourished in cities across Texas. San Antonio alone produced 11 newspapers in Spanish between 1890 and 1900, but El Paso surpassed all other cities in the state. This city produced 22 newspapers in Spanish during that period. El Paso is located on the border with Mexico and has always had a large population of Spanish speakers. Thus, it is unsurprising that this city became such a rich site for Spanish language journalism. It seems like this is all about Spanish language newspapers, and in particular, how prominent El Paso was in the production of Spanish newspapers. So the main purpose would be to explain how El Paso was so prominent with Spanish language journalism. That's what I'm going to say. To compare Spanish language newspapers published in Texas today with ones published there. No. Explain that Spanish language newspapers thrived in Texas, especially in El Paso. Okay, we have especially in El Paso. I like that. I'm going to keep that one. To argue that Spanish language newspapers published in El Paso influenced the ones, no. To explain why Spanish language newspapers, okay, D doesn't even mention El Paso, so boom. My answer is B. All right, I'm moving on to a harder section here. While such amenities were available mainly to town dwellers, okay, so I want to know what the amenities were. Full immersion baths, more affordably steam baths. Okay, while such amenities were available mainly to town dwellers, regular bathing in rivers and streams were common practices. So basically, it sounds like this underlined portion is functioning to say that these fancy things, steam baths, baths, anything other than bathing in the river, basically, were mainly available to people who lived in town versus people who lived elsewhere. That is going to be my anticipation. I want to see if I can get away with not reading the rest of this. It asserts that in medieval Europe, steam baths were more popular in rural areas than urban. No, because in town would be urban. Urban is city, rural is, country. It describes a limitation of earlier historian studies. I don't know about that. It concedes that not all people in medieval Europe had access to public bathhouses. I mean, that's true. I'll leave that one for now. It explains why Janiga decided to study the popularity of public bathhouses in medieval Europe. That doesn't line up with my anticipation. Let's take a closer look at C. So it says the word that's getting me is concedes. The fact that all people didn't have access to public bathhouses should sort of go against something else. If it's a concession, you're saying, even though this is the case. Let's see. According to historian Eleanor Janega, most medieval towns in Europe had at least one public bathhouse. Okay, most medieval towns had at least one public bathhouse. So it does make sense that she would want to concede that not all people had access. When it says most medieval towns, it gives you the idea that there's a lot of people who have access, but then they have to let us know that these are town dwellers. So there's a lot of people who are living outside of these medieval towns who don't have access. So it matches my anticipation, and after looking a little bit closer, it makes sense as well. So my answer is C. All right, we got another underlined portion. And this sentence actually starts at the beginning, just a really long sentence, but let's see if we can still be a little bit lazy. Scholarly accounts of the Chicano movement, and then we have this huge chunk of non-essential information. How do I know? Because there's a dash sandwich. Scholarly accounts of the Chicano movement tend to focus on the most militant, outspoken figures in the movement, making it seem uniformly radical. Okay, it is giving us a reason why scholarly accounts of the Chicano movement might have seemed radical, like why it seemed like a radical movement. And that reason is it focused on really radical people in the movement. So that is my anticipation. I'm going to actually write down my anticipation so I don't forget, because I said scholars focused on radical members of movement. It presents a trend in scholarship on the Chicano movement that the text claims has been reevaluated by researchers in light of Herrera's work on the movement's participants. So the trend would be scholars focusing on radical members. That part sounds true. So I'm going to hold on to this, and I'll look in more detail if I need to in a second. But if I can eliminate these other answers, then I'll just choose it. It identifies an aspect of the Chicano movement that the text implies was overemphasized by scholars due to their own political orientations. All right. This is also matching my anticipation. Overemphasizing radical members. It describes a common approach to studying the Chicano movement that obscures the ideological diversity of the movement's participants. All right, so these are actually looking pretty similar so far. So I want to look a little bit closer at the wording here. Tend to focus on the most militant, outspoken figures of the movement. Scholarly accounts tend to focus on the most militant, outspoken figures. So identifies a common approach to studying the Chicano movement that obscures the ideological diversity of the movement's participants. That also fits. This is a tough one because so far they all fit. Specifically, ideological diversity would speak to radical versus not so radical. So C feels really good. Let me just read through D and then we'll start eliminating. It summarizes the conventional method for analyzing, which text suggests creates a misleading impression of the effectiveness of neighborhood institutions. Okay, D is out. D doesn't match what I was saying. The other three, however, kind of do. I like C the best because of the ideological diversity bit, but let's take a closer look at A. So A, the big thing that's being said afterwards is that the text claims it has been reevaluated by researchers in light of Herrera's work. Let's see if that's true when we look into the rest of this. Herrera has shown, however, that if we shift our focus towards the way movement was manifested, we see participants espousing an array of political orientations and approaches to community activism. Herrera has shown. This says that it has been reevaluated by researchers because of Herrera's work. It doesn't say that here. It just says that Herrera's work shows that this is not the case. It doesn't mention any other researchers, so you can get rid of A. So identifies an aspect that the text implies was overemphasized by scholars due to their own political orientations. Due to their own political orientations, it does not say that. It just says that they focused on the most militant, outspoken figures. It doesn't say why. So this is an inference that's being made. We do not want to go with an inference because it's not actually in the text. B is out. The one that I like, C, is the only one that's left. So that's going to be our answer. All right, to round off our craft and structure, we're going to look at one cross-text connection question, aka when you have not one text, but two. And I do like to start with the question on these as well. That's kind of a pattern you're going to notice in the English section. Start with the question. Based on the text, how would author of text 2 respond to overall argument presented in 1? So I am going to start by figuring out what the overall argument is in text 1. Graphic novels are increasingly popular in bookstores and libraries, but they shouldn't be classified as literature. Okay, overall argument. Seems like I already have it. Argument here, I'm just going to write this. Graphic novels are not literature. How would the author of text 2 respond? Let's see what the author thinks. Graphic novels present their stories through both language and images. Without captions and dialogue, readers would be unable to understand what is depicted in the illustrations. The story results from both text and image. Moreover, Alison Bechdel's Fun Home and many other graphic novels feature text that is as beautifully written as the prose found in many standard novels. Therefore, graphic novel... I really wish I would have started with the last sentence, but boom. Graphic novels qualify as literary text. So basically, we're looking for a complete disagreement. The author of text 2 would say, no, they are literature. By asserting that language plays a more important role in graphic novels than author 1 recognizes, maybe. By acknowledging that the author of text 1 has identified a flaw, no. By suggesting that the storylines of certain graphic novels are more difficult to understand, no, it just says that they're kind of on par. By agreeing that most graphic novels aren't as well crafted, no. So it's got to be A. And we did see a mention of, language playing an important role as well. So there we go. Starting with central ideas and details. According to the text, what was surprising to scientists studying the activity? All right. So these ones, we are trying to pinpoint a detail. So this is where reading the question can save us a lot of time. We're looking for something that was surprising. And I'm honestly just going to kind of skim through the text and try to find that. So it popped out to me. This discovery was surprising to scientists. So the data show that the Mars quakes all started from the same location. So the fact that they all started from the same location, and that's what I'm going to look for in my answer. The surface has been rising, no. 4 different types, no. Less data, no. All quakes started from the same location. Boom, got my answer. Number 12 here, also going to be a detail question. What do some historians suggest about the civilization? And again, I'm just skimming the text. I'm looking for language that could mean historians suggest. In this case, I literally get the words, some historians suggest that Maya mathematicians inherited it. Okay, what is it? The use of zero. So basically, they suggested, and I'm seeing that in the previous one, the use of zero. So they suggested that Maya mathematicians inherited the use of zero from Olmec civilization. That's my anticipation. Maya civilization acquired the use of zero from, that's literally what I said. Maya civilization was highly secretive. Maya civilization tried to, no. So again, boom. Let's look at a main idea question now. For a main idea question, sadly, I won't be able to skim. I'm going to have to read the whole thing and kind of come up with what I think the main idea is. Elizabeth, I'm not going to try to say that, has identified a negative correlation between the share of developing countries' economies derived from natural resource extraction and those countries' receipts of foreign investment. Okay, negative correlation. So let's unpack this a little bit. Negative correlation means as one goes up, the other one goes down. Basically, they don't line up. So we see economies coming from natural resources or natural resource extraction and receipts of foreign investments. So basically, if there's more natural resource extraction, there's less foreign investment and vice versa. Okay, so the second part here, natural resource industries boom bust cycle. I don't know what that means, but I'm going to say boom bust makes unstable. And that's why we see that correlation. Okay, and those two things together. So I'm looking for that negative correlation because of this boom bust cycle. Although it may seem surprising that foreign investment declines in developing countries as natural resource extraction makes up a larger share of those countries' economies, that decline happens because resource extraction requires initial investments too large for foreign investors to supply. Too large doesn't really line up with the boom bust thing that I mentioned, so I'm going to get rid of A. Although developing countries tend to become less dependent on foreign investment, it wasn't about them being less dependent. It was just the fact that they were getting fewer investments when they were doing more natural resource extraction. So B is out. Although one might expect that foreign investment would increase as natural resource extraction makes up a larger share, the opposite happens because heavy reliance on natural resources can lead to unattractive conditions. I don't know what the boom bust cycle is, but maybe it's those unattractive conditions. So let's keep that one for now. Although foreign investors tend to avoid initial investments in natural resource industries in developing countries, foreign investment may increase significantly as those industries stabilize. Okay, it doesn't talk about them eventually increasing. So I'm going to say D is out. Now, by process of elimination, I have C, but let's be careful here. I want to double check. The opposite happens because of heavy reliance on natural resources can lead to unattractive conditions for investors. Let's see if that is the boom bust. Boom bust cycle can destabilize local currencies and increase developing countries' vulnerability to external shocks, creating levels of uncertainty to which foreign investors are typically averse. Unattractive conditions for investors. It's vague, but it matches. External shocks and levels of uncertainty are unattractive conditions for investors. And I'm going to choose C as my answer. That was a tough one, but there you go. Next up, let's do a couple of command of evidence questions. We'll do one sciencey one and one not so sciencey one. So, which choice effectively uses data from the table to complete the statement? So the first thing I like to do for these is to figure out what would effectively complete the statement. And it says, among candidate species for de-extinction, this problem would be especially concerning for the blank. Okay, so what is the problem? Longer it's been extinct, less likely there's a suitable habitat. So basically, concerning for the animal that's been extinct the longest, right? And I don't know what that animal is unless I look at this. chart that they gave us. So I'm going to go ahead and look at the chart. We're looking for the one that's been extinct the longest. 11,000 years ago is certainly more than 6,400 years ago, so it would be the saber-toothed cat. And that's B, and that's our answer. All right, moving on to a non-sciencey one. Okay, so basically it's saying which quotation illustrates the claim. So I want to focus on the claim. And it says, the speaker describes having contradictory feelings while experiencing the sights and sounds of a spring day. So the claim is that this is what the speaker is doing. So I'm looking for contradictory feelings while experiencing sights and sounds of a spring day. Through primrose tufts in that sweet bower, the periwinkle trailed its wreaths, and 'tis my faith that every flower enjoys the air it breathes. I'm not seeing any contradiction there. Like, we're definitely getting the spring vibes from the sweet bower and the periwinkle and all that stuff, but no contradictory feelings. The budding twigs spread out their fan to catch the breezy air, and I must do all I can that there was pleasure there. So again, I'm not really getting any contradictory feelings. I must think that there was pleasure there. The do all I can bit is kind of throwing me off, but I'm not getting any sense of contradictory feelings. The birds around me hopped and played, their thoughts I cannot measure, but the least motion which they made, it seemed a thrill of pleasure. Yeah, here it just seems like the speaker is like looking at birds and thinking, oh man, they're having a good time. I hope D works because I've gotten rid of these other ones. I heard 1,000 blended notes while in a grove I sat reclined in that sweet mood when pleasant thoughts bring sad thoughts to the mind. There we go. Okay. Pleasant thoughts, sad thoughts, contradiction. Thank goodness. My answer is D. All right, let's get a couple of inference questions out of the way here. And these are always going to be the ones that say which choice logically completes the text. Unfortunately, you're going to need to read the entire thing a lot of the time. The Younger Dryas period was a period of extreme cooling from so many years ago in the Northern Hemisphere. Some scientists argue that a comet fragment hitting Earth brought about the cooling. Okay, that seems important. So a comet fragment is one of the arguments. Others disagree, partly because there is no known crater from such an impact that dates to the beginning of the period. In 2015, this team detected a 19-mile wide crater. The scientists who believe an impact caused the Younger Dryas claim that this discovery supports their view. Okay. However, their team hasn't yet been able to determine the age of the crater. Therefore, the team suggests that, well, if we don't know the age of the crater, I would say they should suggest that we either find the age of the crater or that we don't have enough evidence to support the comet fragment thing. It can't be concluded that the impact that made the crater was connected. That's true. It can't be determined whether a fragment could make a crater. No. Scientists have ignored the possibility. No. The scientists who believe the impact Younger Dryas have made incorrect assumptions about. No. So yeah, A, we don't know yet. It can't be concluded. Might as well just do this one next door here. In 2016, biological anthropologist and her team investigated evolution of the appendix, an intestinal organ that's present in some mammals, including humans, but is generally thought to have no function. They studied a bunch of mammals, found that the appendix has emerged independently across multiple lineages in separate instances. Okay, so basically has emerged independently. So it's showing up in all these mammals. Hasn't disappeared after emerging in different lineages. Moreover, the team determined that the species with the organ tend to have higher concentrations of lymphoid tissue, which supports immune responses. The organ the appendix is attached to. Therefore, the team hypothesized that the appendix likely blank. The fact that it emerged independently and that it is connected to something which supports immune responses, I'm going to say actually is important, has something to do with our immune system. Was once present in many non-mammal species but has since disappeared. No, it said that it's appeared independently. Has been preserved in certain mammal species because it benefits their immune systems. Yes, I said that. Will emerge in a greater number of mammal species because it may serve a necessary function in the immune system. Will emerge? No, we're not trying to predict the future here. Produced higher concentrations of lymphoid tissue in mammals in the past? No, that was just like one little detail when they talked about the lymphoid stuff. I don't remember what it was, but it was a detail. So B is my answer. All right, one more. This one should be a little bit more challenging. The practice of logging is often thought, and you might notice I'm skipping a lot of stuff. If I see parentheses, if I see 2 dashes, I'm going to skip stuff because it helps my brain concentrate. The practice of logging is often thought to be at odds with forest conservation. However, a massive study in forest management and preservation spanning a bunch of hectares and organs, whatever, calls that view into question. Again, I'm skipping details in my mind. So far, results of the study suggest that forest plots that have undergone limited logging may be more robust than plots that haven't been logged at all. Okay, so that seems to be the main idea. So basically, if there's been a little bit of logging, they're more robust. So there's more trees than plots that haven't been logged at all. So it would suggest maybe that a little bit of logging is actually good for forests. Logging may be useful for maintaining healthy forests, provided it's limited. Yes. Other forest management strategies are more effective. No. As time passes, it will be difficult to know whether it has benefits. No. The best way to support forest health may be to leave large forests entirely untouched. No. So yeah, A. Not sure why that was in the harder section. That one was actually pretty easy. All right, moving on to my favorite, some standard English conventions. Ming became the 13th Secretary General of the Association in January 13th, making blank the first time the organization would appoint a Vietnamese leader. So this is a pronoun question. We have a bunch of pronouns, and the easiest thing to do is to figure out, are we singular or plural? So this is an event. This thing that happened where Ming became the 13th Secretary General was an event. An event is one thing, so I'm going to get rid of plural answers. These, those, some. My answer is this. A decade later, Land blanked his technology to invent the world's first instant camera. A decade later sounds like we are in the past. It's telling a story. A decade later, Land used his technology. Yes. A decade later, Land to have used his... No. Land to use... No. No. Okay, it's A. Using one of these non-copyrighted songs, blank a creator won't lose advertising revenue. So we have a verb tense, and I like to find the subject. So the subject is using one of these copyrighted songs. Kind of a weird subject, but we could simplify this into a pronoun. Using one of these non-copyrighted songs is like, it's an action. It's something that happens. Doing this thing. So we could say it. It is an event, singular. It are insuring, no. It have insured, no. It insure, no. It insures, yes. So again, change it to a pronoun. We're looking for singular or plural. It's singular. This is the only singular answer. And if you're not sure, you can literally just look at the answers. There's usually only one that works. So even if we didn't know that this part that's underlined was singular, we could see that all three of the other answers are plural. The odd one out is more often than not going to be your answer. In fact, let's play with that. We have a bunch of verbs. We have represents, singular. He represents. He has represented. He was represented. They represent. The odd one out is they represent. And sure enough, we have such iconic references. Plural. Plural. Boom. And notice for these, I'm really trying to be lazy and just focus on the sentence with the blank space, unless I need to look further. When you place your hands between the two antennas, the pitch will shift. So here, if we look at our answer choices, we're trying to figure out if we want to use apostrophes or not. So if we have hands apostrophe, that should mean that the hands possess something. Hands between. Do you have a between? Does anybody possess a between? No, between is not a noun. So any answer that has hands possessive is out. This has plural hands possessive. Plural hands possessive. Also out. It has to be B. All right, let's find some more challenging ones in one of the challenging sections here. Clear glass, which is classified as transparent, allows all light to pass through wax paper, which is classified as translucent. All right, so here we're looking at punctuation. Clear glass, I'm going to get rid of this to make things easier on myself. And, when you're going through, you can just sort of mentally ignore this. I just want to show you what I'm choosing to mentally ignore. Clear glass allows all light to pass through wax paper, which is classified as translucent, allows only some light to pass through. Oh my goodness. Okay. Something weird is happening here. The way that I just read it, it doesn't work, right? Because we have, which is classified as translucent, allows only some light to pass through. Because I was reading it like there's no punctuation, so I'm going to know immediately that B doesn't work. Let's go through the answers and just see what's going on here. Clear glass allows all light to pass through, comma. Wax paper, which is classified as translucent. Okay, so now I'm understanding what happens. We have clear glass allows all light to pass through, period. Wax paper allows only some light to pass through. That's another sentence. We don't have a period, but what acts just like a period? You're right, a semicolon. C is our answer. Using natural debris, such as dried leaves, man-made trash, such as plastic bags. Okay. I'm immediately recognizing that this is the semicolon rule that is somewhat new to the digital SAT exam, where basically we can have a list and we can use semicolons to separate items in that list, as long as the items in that list have additional punctuation in them. Usually, the additional punctuation is, more commas. So we can see here we have natural debris, such as dried leaves. So that's the first item in our list. And there's a comma that is a part of that item. Man-made trash, such as plastic bags, comma, which is part of that item. And more traditional art supplies, such as glue tree. So again, we have that comma. And I'm circling the commas because this is what's needed for us to justify using semicolons in our list instead of commas in our list. So basically, I want a semicolon. And where do I want the semicolon? I want it right there after leaves. Only 5 of these dances are included in the ballroom dance competition, however. Rumba, samba, cha-cha, all this stuff. Okay, so I'm pretty sure I know what's going on here. We're going to have only 5 of these dances are included in international ballroom dance competitions, however. That is a full independent clause, but we have a list afterwards. What's really good at introducing lists after an independent clause? Colon. My answer is A. All right, we'll do one more of these. When it comes to their diets, goats are notoriously blank. When it comes to their diets, goats are notoriously indiscriminate. They will devour all. Okay, so if we had and, they're notoriously indiscriminate and they will devour all kinds of shrubs and weeds, leaving. So all this is being added on to the end of the sentence, but we could think of this as a full sentence, right? Goats, we'll get rid of the introductory phrase too. Goats are notoriously indiscriminate and they will devour all kinds of shrubs and weeds. We have 2 full sentences and we have a coordinating conjunction here, and we need a comma before that and. A doesn't give us that comma, so A doesn't work. B, we don't have and, but we still have 2 full sentences. Goats are notoriously indiscriminate. They will devour all kinds of shrubs and weeds. That is a comma splice, aka a comma trying to act like a period. Not okay. C doesn't even do the honor of giving us a period. C is out. It has to be D. And let's talk about the colon for just a second. So I said that colons are really good at introducing lists. They're also really good at giving examples. We have goats are notoriously indiscriminate. Here's an example. They'll devour anything. That's the definition of being indiscriminate, right? They don't care. They'll eat whatever. So we have an example. All right, let's finish up the English section with expression of ideas. That is transitions and rhetorical synthesis. First one is a transition. Historians agree that jazz pianist Jelly Roll Morton was exaggerating when he claimed to have invented jazz music. No one can deny that Morton's... Okay, so they agree he was exaggerating. No one can deny that his innovation helped shape jazz as a genre. So he didn't invent it, but he did help shape the genre. So I'm looking for like but or however. Therefore, in the second place, that's a weird one. In other words, though. Though is the same as however and the same as but. And for these, I do like to try and just read the sentence before and then the sentence with the blank space. This technique involves smothering the flame surrounding the clay vessel. The vessel takes on a shiny black hue. So it seems like you do this thing and then the vessel takes on a shiny black hue. So I'm looking for like, that's what happens after you smother it. On the contrary, no. For example, no. Previously, no. As a result, yeah. We do this thing, and because of that, as a result, it takes on a shiny black hue. According to Duverger's law, according to Duverger, what is that name? Duverger's law, countries with a single ballot majoritarian elections for single member districts tend to polarize. And okay, according to this, these parties tend to, I'm focusing on the meat and potatoes here, at least what I see is the meat and potatoes, tend to polarize into two-party systems, wherein dueling political systems constantly dominate. So basically, you have all these two-party systems that dominate. Countries with proportional representation electoral systems, these other systems, tend to support multi-partyism. Okay, so we're looking for a contrast. These countries have two-party systems. These other ones have multi-party systems. So conversely, and that one just jumped out at me. I do like to eliminate, but I saw conversely because that's literally like, opposite of this is this other thing. All right, let's do a couple challenging ones. The liquid metals on Earth's core circulate constantly. The circulation generates electrical currents that flow between the north and south magnetic poles. These currents create a barrier around the Earth. Okay, so it seems like it's just continuing to explain what these currents do. So I'm looking for like, it could be like as a result, not quite as a result, but like the next step or like here's more information. Let's look at my options here. In turn, that actually makes a lot of sense because it says they flow between the poles and then in turn, like as they do this, they create a barrier around the Earth. And then these other ones, likewise, no. Nevertheless, no. In reality, no. So in turn is going to be my answer. Again, in turn, it would be first we're talking about liquid metals circulating, and that creates electrical currents. In turn, the electrical currents create this other thing. So it's like this creates this, in turn, this creates this. Then the site is carefully dug, and any artifacts found are recorded and mapped onto the site grid. The artifacts are removed, cataloged, and analyzed. This seems like we have just an order of things. Then, so what's the first one? After permissions granted, a dig begins, then, and we should have finally. That was easy. What is this doing in the hard section? Okay, so this is a semicolon, which is basically a period, so I'm still going to start from however here. However, the differences between the first edition and the 1908 edition are extreme, even by James standards. Some critics regard the two editions as two different novels altogether. Okay, so it seems like It's giving an example, so we should have some sort of an example intro. By contrast, not an example intro. In fact, yeah. Nevertheless, no. In other words, no. In fact is a way to give an example, especially an emphatic example, an example that emphasizes what was just said. All right, finally, rhetorical synthesis. And these are super easy. We are going to ignore the notes, go down, and find what the goal is. The goal is to identify the real author of Adam Bede. Cool. The real author was Marianne Evans. That seems to do it. George was widely assumed. Nope. The title indicated nope. Woman who had a pseudonym. Okay. A woman who had used a pseudonym to conceal her identity later revealed herself as the real author. So A and D both are identifying the real author. However, D doesn't even say her name. It just says that she used a pseudonym. So it's A, because A actually says it was Marianne Evans. Boom. See? Told you those are easy. Let's just skip to some harder ones so you can see that even the harder ones are not so bad. All right, we're going to do the same thing. We want to emphasize the similarity between the code talkers. U.S. soldiers who are members of the Choctaw Nation in Oklahoma use their native language. No, that's not talking about both. We want to identify a similarity. In World War II, one group of Navajo soldiers was known. Again, we're not talking about both. Both the code talkers from Choctaw and the Navajo code talkers transmitted coded military messages in the soldiers' native languages. That does seem to emphasize a similarity. The Choctaw code talkers, not the Navajo code talkers, served. Okay, so it's C. See? Don't even need to look at the notes. And this is in the hard section, mind you. So they're really easy if you know what to do. All right, we'll do one more to finish up here. And then this one, we want to contrast number of meteorite falls with number of meteorite finds. So contrast falls with finds. A meteorite was observed falling to Earth before being recovered is known. That's not talking about the number. Meteorites found on Earth are divided into two categories. Nope. There have been about 1,200 recorded meteorite falls. Nope. Because it's not mentioning the finds, only the falls. While there have been 1,200 falls, there have been over 60. Yeah, so that's the only one. And again, this is in the challenging section. It's not challenging. You just need to find out what the goal is, choose the answer that does that. We don't care about the notes. All right, before we get into the math section, just a quick tip for you. Go to Desmos.com, go to Math Tools, and then you'll see all these different calculator options. Click on Test Practice, and then you can choose the digital SAT. Boom. That way you know for sure you're using the proper calculator, but it's the graphing calculator. And also, do not forget to go to your reference page if you're practicing and it's not Bluebook practice. And remember to use this reference page if you ever come across a geometry problem and you forgot a formula. All right, solution to this is going to be where they touch. This point right here, which is 4, 5. Boom. For word problems, even if they're short, I like to go to the last sentence and get the main question. If no members leave the film club, how many total members will the film club have 4 days after the first semester? That seems to be the main focus. So how many 4 days after the first day? On the first day, it has 90. And then each day after the first day, 10 members join. So we have a constant rate of change. 10 members are joining. 10x. We started with 90 plus 90. So this is a linear equation. And if it's going to be 4 days, then that would mean x is 4. So basically 10 times 4 is 40. 40 plus 90 is 130. Boom. What is the y-intercept? The y-intercept is where it touches the y-axis, which is 8. So 8, 0. Remember the first one is x. 0, 8. That's D. Solution to the system of equations. So system of equations, you can certainly use your graphing calculator, but this one is so easy. It's early on. It's telling us what R is. We just have to plug R in. Basically, we're just going to plug in that 3 for R. S plus 7 times 3 equals 27. 7 times 3 is 21. S, and let's actually subtract that 21 from both sides. S equals 6. And then it says the solution is RS. They already told us R is 3, so 3, 6. What's the best description? Basically linear versus exponential, increasing versus decreasing. So we have definitely linear, because we can see that we're adding 1 every single time. And then is it increasing or decreasing? It's increasing, so increasing, linear. What is the value of x in the solution? The solution, again, is where they touch. The value of x is 4. What is the value of x minus 7? All right, what I like to do is try to just get x minus 7 if possible. So first of all, let's move everything over to the right side. So x is on the left side. So 4x will add 28, right? So negative 24 plus 28 would equal 4. Then x equals 1. Well, at this point, basically 1 minus 7. Okay, 1 minus 7 equals negative 6. If this day has 670 minutes of daylight, how many minutes of non-daylight does it have? Okay, x plus y is number of minutes of daylight. X, all right, so which one is 670? X and the number of minutes of non-daylight. Okay, so x is the minutes of daylight. So basically, oh, it's just one plus the other. So 670 plus y equals 1440. We're going to subtract 670 from both sides. I'm going to grab my calculator. 770. Boom. What is the slope of line J? All right, so it's telling us about line K, and it's saying line J is perpendicular. Well, that's easy. Perpendicular means it's going to be the inverse slope. I think that's the correct term. Basically, it's the negative reciprocal. So y equals mx plus b, m being 7 is our slope of the original. So the reciprocal would be 1 over 7. And then we add a negative. So it should be negative 1 over 7, aka b. So for this one, it tells us it's a linear relationship. We need to choose the equation that works. The answer choices aren't in a format I love. I prefer slope-intercept form, but we can basically just plug in these numbers and see if they work or not. So let's test out A. Number of cars should be 3. So basically it would be 55 times 3 minus P minus 174, and that should equal negative 9. Let's see if that works. That does indeed equal negative 9. Just for good measure, let's test the others. All we have to do is switch out the numbers. So 5 and then 284, also negative 9, 10, 559, boom. We've checked, we are golden, it's A. Again, the power of using your calculator. What is the range? The range is the biggest number minus the smallest number. It looks like they put it in order for us. Very sweet of them. 52 minus 23, 29. Which of the following is the best estimate for the number of employees at the company who are enrolled in exactly 3 professional development courses? So 3 courses, exactly 3. And it also says best estimate, so if it's not perfect, that's fine. Now let's see what's going on. 20 employees selected at random from 400. Okay, so basically it's a ratio, right? Because we're saying 16 out of 20 were enrolled in exactly 3 courses, but we're trying to figure out the best estimate of all of them out of the full 400. So we could write it like this, right? A little cross multiplication here. 20x, whoops, equals, all right, and I'm going to go ahead and grab my calculator. 16 times 400, 6,400, and divide that by 20. Well, if we divided it by 10, it would be 640. And then if we divided it by 20, it would be 320, right? If Brian continues at this rate, how much money will he have in 9 weeks? Well, let's see. He gets 2/5 of 215 every week. Okay. So basically we want to start by 2/5 times 215. And I'll just throw that into my calculator because I can. 86. 86 times 9. We're just going to throw that in as well. 774. So our answer is 774. What is the median? The median is the middle number. So what we can do is we can start crossing off from the biggest and the smallest. The biggest is 18, goodbye. Smallest is 4. New biggest is 10, goodbye. Smallest is still 4. The new biggest is 6. The smallest is still 4. And then we have 2 numbers left. We take the average. The average of 5 and 5 is 5. So our answer is 5. Which of the following could be an equation for dataset F? It's specifying dataset F, so I'm going to double check the beginning to make sure that this is dataset F. And we see that it is in fact not. It is dataset E. Dataset F is created by multiplying the y-coordinate of each point by 3.9. So basically we want to say y times 3.9 is going to get us to the dataset we're looking for. And then all of these are, in slope-intercept form. They just stuck the y-intercept in front instead of at the end. But let's check the y-intercept first. It looks like the y-intercept here is 12, which means if we multiply by 3.9, it's not going to be 12. So it's not C or D. And then we need to look at the slope. So what is the slope going to look like? I could do the slope formula here, change all the y-coordinates and mess with that. Or I could just plug in the equations to Desmos and see which one matches. I think I'm going to use Desmos because I'm kind of a lazy guy. So the first one is y equals 46.8 plus 5.9x. All right. And let's look at a point that's easy to spot here. So we have 2. These are going up by 2. So this would be like 2 and then roughly 15. But then what's 15 times 3.9? Basically 15 times 4, it should be close to 60, right? And these are pretty different, so I think we're okay guesstimating here. So we're looking for something close to 60 at the 2 mark. All right, so I can already see it here. We have 1, 2, and it's getting close to 60. It's up to 59, pretty much. So that's our answer. A. What statement is true? Now, even here, I'm skipping to the main question because basically the first part, whenever you have one of these types of diagrams, is just saying it is what it looks like. So we can tell that these are parallel. It's just letting us know that these are parallel. And we can tell that this is intersecting both lines, but it's telling us that. So normally I'll skip that. Anyway, we can just go through and eliminate whatever's not true, right? Value of x is less than 145. No. These are vertical angles. Vertical angles are congruent, so x actually is 145. So that's not true. That's not true. It's C. What is the height of the cylinder? All right, they're telling us about a cylinder. Anytime you have geometry, I definitely recommend drawing. So we're going to draw this beautiful, beautiful cylinder here. And the volume is 432. The area of the base, we'll call this the base. Area of the base is going to be 24. What is the height? So we could use our cheat sheet if we don't remember, but basically the area of the base times the height is going to equal the volume. So we could say 24 times something equals 432. Divide by 24, 18. I'll be darned, there's 18 right there. What is the length of the diameter of the circle? Okay, this one I think we're really going to have to see what's going on so that we can kind of visualize it. It says a rectangle is inscribed in a circle. The corners are going to be touching. It's going to be as tight a fit as possible. So to visualize this, let's get ourselves a circle. Maybe change the color to something other than white so we can actually see it. A rectangle is inscribed inside a circle. And it does say it's a rectangle. I'll do my best. I make no guarantees. All right, so there we go. Such that each vertex lies on the circumference of the circle, the vertexes being the corners here, right? The diagonal of the rectangle, so that's going to be if we cut it in half, let me actually get another color for this as well, is twice the length of the shortest side. So basically this is like, we could call it 2x, and then the shortest side would be just x. And I don't know if this looks familiar to you or not, but this is a rule that we'll see on the cheat sheet. I'll just pull it up so you could see it real quick. It's one of our special right triangles. We have x, 2x, which means the other side is x root 3. And then it says the area of the rectangle is 1089 times the square root of 3, which makes sense because we know that the height involves the square root of 3, right? So really, we could just get rid of that, say that the area of the rectangle is 1089. What is the length of the diameter of the circle? The diameter being the diagonal, right? So if x squared equals 1089, what is the square root of 1089? 33. So x equals 33, and 2x is the length of the diameter, so 2x would equal 66, which is our answer. What is the area of EFGH? Okay, so it's telling us that the rectangles are similar. Similar means they have the same proportions. The length of EFGH is 6 times the length of the corresponding side of ABCD. The area of ABCD is 54. So the area is 54. But we have to think about not the area, but the side lengths. So basically, length times width equals 54, right? Now, the cool thing is, it doesn't matter what length and width are. They could really be anything. So let's just decide what we want them to be. 6 times 9 is 54. So let's just say that the area or the length and width of the originals are 6 and 9. And then we know that the length and width of the other ones are going to be 6 times the amount of the first one. So 6 times 6 is 36. 9 times 9 is 81. 36 times 81, I'm going to guess, is 1944 because all the other numbers are too low. I'm not even going to use my calculator because that would be a waste of my valuable time. Now notice that 54 times 6, if we just multiplied the area by 6, it'd be 324, which is a wrong answer here. The reason we can't do that is because when we go up to area, we are multiplying length times width. So the scaling changes after that. So be careful you don't fall into that kind of a trap. That is not our answer. What is the width of the rectangle? All right, so it's telling us about a rectangle. I'm gonna quickly draw one out here. The area is 155. I like to put that in the middle if it's the area. Length is 4 inches less than 7 times the width. Okay, so L equals 7 times the width, 7W, 4 inches less than that, minus 4, right? So basically, we have 2 of those, 7W minus 4, 7W minus 4, and then the width is the width. So we could just put W's all around. And then we know that the area is the length times the width, right? So we can say 7, I'm going to move over here, 7W minus 4 times W should equal 155. 7W squared minus 4W equals 155. And then we can see this is basically turning into a quadratic. 7W squared minus 4W minus 155 equals 0. And I don't like how big these numbers are, so I'm just going to put that into Desmos. And of course, we're going to change w to x, so 7x squared minus 4w, or 4x, minus 155. It always has to be the positive, and the answer is 5. Power of Desmos. This one, we want to start by drawing this circle that they're telling us about. It's also telling us we have A and B on the circle where A is, okay, this is HK. So could also just remember that that's HK. And then talking about A, it says point A has coordinates of H plus 1. H plus 1. So basically A is going to be 1 to the right, so a little bit to the right of the center, and K, the y coordinate, plus the square root of 102. Now we're going up the square root of 102, and that's where point A is going to be. And then point B, it doesn't tell us anything. So point B could be, oh wait, no, it does. APC is a right angle. So then from C, here, let's draw this triangle. We want a right angle. So that's 90 degrees. Let's deal with what's going on here, and then we can maybe put in the 90 degrees. So we know that this pink line is the square root of 102, right? But what we need to know is the length of AC. Sorry, I need to write in B here too. What we need to know is the length of AC, because AC starts from the center of the circle, which means it's a radius, and CB goes from the center to the outside of the circle. So it is also a radius, which means if we find AC, it's equal, it's congruent to CB. So how the heck do I find what AC is? Well, that's going to be pretty easy, because we already know that one side is the square root of 102. I forgot to label it, but when I made that little arrow, I was saying that's 1 over, right? So the length of this one is 1, and then we can just use the Pythagorean theorem. A squared plus B squared equals C squared. In this case, our hypotenuse is going to be the longest one. We know that the radius is going to be the longest possible value inside of the circle, so it'll be the unknown. A squared will be 1. 1 squared is 1. Square root of 102 squared is 102. So that's going to be 103. So then the square root of 103 is the length of AC. And that means the length of CB is also the square root of 103. And it's asking us the length of AB, which is our hypotenuse. Well, we know that this is 90 degrees here, which means we have a 45, 45, 90, because we have two equal sides, which means two equal angles. And with a 45, 45, 90, you have this rule where, and again, this will be on the cheat sheet if you want to just look at the cheat sheet. We have x, and then x times the square root of 2. So basically, what is the square root of 103 times the square root of 2? And the cool thing is, there's this really cool trick where the square root of A times the square root of B is the same as the square root of A times B. That is to say, we just have to multiply 103 times 2, and that would be 206. What's the positive solution to the equation? Well, there's only one positive solution, x equals 5. Because basically, all the stuff in parentheses, you flip it, those are your three solutions. So x equals -2, x equals +5, x equals -9. How many real solutions does the equation have? Well, if you square something, it's always going to be positive. So that would be 0, because this is negative. All right, what is the value of C? So this is an exponent-based problem, and it looks kind of scary, but if we can get the two sides to look like each other, it'll be less scary. I like the way that the left side looks, so I'm going to try to convert the right side so that it looks more like the left side. So a cube root is the same thing as raising to the 1/3. So basically, 4 to the 7th is what's under the cube root. That is being raised to the 1/3. And then we could apply another rule where we're allowed to multiply exponents that are being raised. Like if an exponent's being raised to an exponent, we could multiply. So basically 4 to the 7/3. And now we have this thing where if two sides of an equation have the same base, we can get rid of the base. So we have a base of 4 and a base of 4. And now we just have 8c equals 7/3. We want to divide by 8 to get rid of the 8 on the left side, which is the same as multiplying by the reciprocal. So I'll just times 1/8 equals 7/24. And we could write that as our answer or decimals. So 7/24. Not sure why it didn't show up, but there should be parentheses here. So I'm just going to put those in real quick. Which of the following is the closest to the value of p? We would want to change this 0.84 into 84/100, right? That's what it looks like. But we also need to note that this is x/4 originally, but then it changes to only x. What the heck, right? So let's try to change the original equation so that it is to the x instead of to the x/4. We could think of it as x times 1/4 or 1/4 x, right? And since they're being multiplied, we could also say this is equivalent to 1.84 to the 1/4 to the x. Because remember, if we're multiplying exponents, that's the same thing as raising an exponent to an exponent. So let's throw this into our calculator, 1.84 to the 1/4. All right, 1.16 roughly. So then 1.84 becomes 1.16. P/100, how do we get 0.16? 16/100. Boom. Answer is 16. All right, this is going to be our last question. We have a system of equations, and it looks pretty scary because we have a constant involved as well. At least I think it looks scary. If you have a scary system of equations, I recommend using Desmos. So let's literally just plug these into Desmos. 48x minus 64y equals 48y plus 24. And ry equals, sorry, I can't see my line there. Okay, there we go. ry, you just type in a letter, by the way, equals 1/8 minus 12x. And then it's asking us if we want to add slider r. Yes, we do, because we're trying to figure out what r is. So we can play with r basically like this. Now, what do we want r to be? Well, it says the system has no solution. If you don't know this already, no solution means same slope, because it means they will never, ever touch. The only way that's going to happen is if they have a different y-intercept and the same slope. So I'm just going to go to Desmos and I'm going to mess with r until they have the same slope. Okay, we need to change our slider here. Sorry, the step, it was only going down to 10. So I'm going to go minus 100 and then 100. This is like how far we're allowed to go with our, I'm going to use a whole number for now. Okay. Anyway. Okay, that's actually looking like it has the same slope right there. All right, so we got the same slope here. R equals -28. And of course, you could play ring around the rosy and use substitution and whatnot for this, but why would you do that when you can just jump into Desmos and get your answer so quickly? So that's my 2 cents. We do hope you found some value in those tips. And if you're looking to really boost your SAT score, you might want to consider signing up for one of our small group courses. These courses are designed for those students who thrive in a more collaborative group environment. Courses are available with 12, 24, or 36 hours of expert instruction from one of our tutors. Each course includes 5 full-length practice exams and detailed score reports breaking everything down so you know exactly what you need to work on. Go ahead and use the link in the description to get signed up for a small group course with Revolution Prep right now.